Avi Loeb, welcome to the show.
Thanks for having me. It's great to be in farmland.
I'm really excited about this interview. You popped up on my radar from a gentleman that I interviewed about a month ago, Tim Gallaudet, who's part of your Galileo Project, and started looking into you, and I love the stuff you're talking about. I'm fascinated with all of the topics, and so thank you for coming. I'm really excited to have you.
Thanks for inviting me.
My pleasure. So we're going to talk about a number of things. We're going to talk about black holes. We're going to talk about extraterrestrials, the Galileo Project, and some of the other stuff that you are involved in when it comes to outer space. And so should be a very fascinating interview. And if you don't mind, I'd like to introduce you real quick. You have a long introduction, lots of accomplishments, and just fascinating things that you've been involved with. So here we go. Abraham Avi Loeb, born in 1962 in Israel. You are an Israeli-American theoretical physicist, received a PhD in plasma physics at the age of 24, a Frank B. Baird Jr. Professor of Science at Harvard University. You are the founding director of Harvard University's Black Hole Initiative, head of the Galileo Project. You hold a visiting professorship at Weizmann Institute of Science and a senior professorship by special appointment in the School of Physics and Astronomy at Tel Aviv University. Director of the Institute for Theory and Computation at Harvard, Smithsonian Center for Astrophysics, the former chair of the astronomy department at Harvard University 2011 to 2020, former member of the President's Council of Advisors on Science and Technology, and a former chair of the Board on Physics and Astronomy of the National Academies. A fellow of the American Academy of Arts and Sciences, the American Physical Society, and the International Academy of Astronautics. You have published popular science books, including Extraterrestrial, The First Sign of Intelligent Life Beyond Earth in 2021, and Interstellar, The Search of Extraterrestrial Life and Our Future in the Stars in 2023. Your book, Extraterrestrial, became an international bestseller and was translated to 26 languages. In October of 2023, you received the Cosmos Award for it. You were named 2012's Time Magazine's 25th most influential people in space. You have authored over 1,000 research articles and 8 books. Netflix is producing a documentary about your research to appear in 2025. I can't wait to see that, by the way. On February 16th, 2024, you were the first scientist invited to speak for 45 minutes at the Munich's Security Conference in Germany. A day later, you were invited by the Polish government to deliver the keynote lecture in celebration of the 550th year anniversary of the birth of Nicholas Copernicus. Did I butcher that?
No, that was fine.
At his birthplace of Turin, Poland. The title of the lecture was The Next Copernican Revolution. You are fundamentally a curious farm boy,
right?
And to this day have no footprint on social media.
Right. We could have saved a lot of time if you just said the last sentence first. I was born on a farm and I'm curious, that's all.
You were born on a farm.
Yes.
What did spark your curiosity in outer space? I mean, we had a brief discussion about this at breakfast.
Well, as a kid, I was really wondering, about the world that I was born into. My mother told me that in the delivery room, I looked very different than the other babies. They were looking around and I was looking up. And since then, I didn't stop to look up. So as a young kid, I would drive a tractor to the hills of the village where I was born. I used to collect eggs every afternoon. We had the chicken. And I would read philosophy books because they asked the most fundamental questions about our existence. And I really wanted to pursue a life of full of curiosity, trying to figure out answers to the most basic questions. And since I was born in Israel, you don't have that privilege at age 18. Everyone is drafted to the military. And I preferred, since I was good in physics, I preferred to actually do something that is closest to philosophy, which was pursuing research in physics. And at the time, there was a new program that was established that allows its members, 30 of them, that they selected out of thousands, to study physics and mathematics and then use it for the defense of the country. And during that time that I was there, between age 18 and age 26, I got my PhD at age 24, working on basically very hot gases that are generated when you release a large amount of energy in a small volume. And at the time, the Strategic Defense Initiative was announced by President Reagan. And we proposed a project that was the first international project to be funded by the US. And thanks to that, we received millions of dollars a year. And I came to Washington quite often. And in one of the visits, I was advised to visit Princeton, the Institute for Advanced Study, where Albert Einstein was faculty a few decades earlier. And I went there. At first, they said, show us your credentials. The administrator there asked me for my publications. I sent what I had. And then when I arrived there, she said, there is only one person here that has available time to speak with visitors, and that's Freeman Dyson. And she introduced me to Freeman, and then he introduced me to an astrophysicist, John Bacall. I didn't know John. I didn't know much about how the sun shines, and I had no clue about astrophysics, but he took a gamble. He offered me a fellowship for 5 years at Princeton after I finished my military service, under one condition, that I'll switch to astrophysics. And it's kind of an offer that you cannot refuse, just like in The Godfather. And so I accepted it, even though it was not really what I wanted to do. And then there was an opening at Harvard, and nobody wanted that position. In fact, they offered it to someone who declined it, and then they went for me. So I said, okay, well, again, it doesn't come very often, so I'll take it, because other people appear to be, to have some respect for that university. And the chances of getting promoted was very small. They didn't promote from within. And so after 3 years, they gave me tenure because Cornell University wanted to hire me. And so at the end of this, it was like an arranged marriage. But I realized that I'm actually married to my true love, because there are fundamental questions, philosophical questions, that we can address with the scientific method. And all of this to say
what would some of those questions be?
For example, how did the universe start? We know that the universe is expanding. So if you reverse the movie back in time, it was denser and denser as we go back in time. And there was a point in time when the density of matter and radiation was infinite. It's called the Big Bang. That's when everything started. There was an initial point in time. And by the way, this philosophically is not very satisfying, because you want to ask what happened before the Big Bang. And Albert Einstein actually resisted the idea that there was a beginning in time, even though this is the version that appears in the Old Testament. So what happened before the Big Bang? That's a fundamental question. And, nowadays, when I think about it, I realize, Einstein's theory breaks down at the Big Bang because the density of matter and the curvature of space and time become infinite. But we know that if there was a theory that unifies Einstein's gravity with quantum mechanics, another pillar of modern physics, we would have potentially understood what happened before the Big Bang. It's just that we don't have that theory. So then I can imagine that maybe there was a quantum gravity engineer It could be a scientist or an engineer from another civilization that had that knowledge and knew how to create a baby universe in the laboratory. And maybe our Big Bang was created by an extraterrestrial in a white lab coat. That's a possibility. All I'm saying is this is a fundamental question. Of course, religions have another take as who created this thing that we live in. By the way, one thing to keep in mind, it started really simple. You can describe the initial conditions of the universe on a single sheet of paper. And it became complex because of gravity. The universe was uniform to start with to 1 part in 100,000. But then regions that were slightly denser than average acted upon themselves by gravity and condensed to make bound objects like the Milky Way galaxy that we live in, inside of which you have stars like the sun, and next to which the debris from making the star coagulated to make a planet like the Earth that we are sitting on. So all the complexity we see on Earth that you cannot summarize, in thousands of books, all of that came from very simple initial conditions. And if I wanted to create the simplest universe possible, ours is pretty much it. And so what started it is a good question. And how did we get all this mess that we see around us, including in politics, from those very simple initial conditions? If you just start with those conditions, you'll end up with all the mess we see around us, which is amazing by itself.
How do we know that the universe started with the Big Bang?
Because we can see what is going on right now. It's expanding.
And so is the expansion...
So we go back in
expansion like a shock wave?
No. It's actually... the way to think of it is like a balloon that is blown up. So the surface of a balloon is two-dimensional. There are two dimensions that describe it. That's the only difference from space itself expanding in the universe, because that is in 3 dimensions. But other than that, if you imagine, marking dots on the surface of the balloon, they would recede away from each other as the balloon expands. So in the same way, galaxies like the Milky Way that are spread all around the universe, they are receding away from each other because space itself is expanding.
So does that mean every second distant galaxies, planets and stars are
moving away from us
in distance,
as if they don't like us? But it gets more extreme than that. When I came to Harvard, I gave a course in cosmology, and one of the students in my class told me that what I said in that class motivated him to pursue a new line of research that ended up concluding that not only the universe is expanding, but the expansion is accelerating over time. That student was Adam Rees.
That's factor theory.
He got the Nobel Prize for it, together with 2 others. So we now know that other galaxies are running away from us at an ever-increasing speed. And this started when the universe was roughly half of its current age, that it started to accelerate. It's as if gravity is repulsive. And you can understand that because when you look at Einstein's gravity, if the vacuum is what is left after you remove all the matter, in a box. If the vacuum itself has some mass per unit volume, some mass density, that creates repulsive gravity according to Einstein's theory of gravity. And that's what we see in the universe. So we realize that the universe initially expanded. The mass budget was dominated by matter and radiation, but once they got diluted enough, the vacuum started dominating, and the vacuum is causing this accelerated expansion. So that's what we see now. And what it means is, if you have a friend in another galaxy far away, at some point in time, that friend will be carried away from you at a speed larger than the speed of light. So you won't be able to get any Instagram updates or from that friend beyond a certain point in time. It's just as if the friend fell into a black hole. Because the same thing happens if your friend crosses the event horizon of a black hole, the image of that friend fades away and freezes at the last frame of that friend when they cross the horizon. So that's the only information you have, because no information can escape from inside a black hole. Mm-hmm. And the same is true for crossing the cosmic horizon, the edge of our universe, by a friend that you have in a galaxy that is receding from us faster than light. And you might ask, how is it possible for something to move faster than light? Because after all, the speed of light is the maximum speed that any material object can move at. Well, that's true, according to Einstein, only when you deal with things close to you. But imagine again this balloon, and imagine ants walking on the surface of the balloon. So the ants walk at some speed, but if we blow the balloon fast enough, then the separation between the ants will grow faster than they can traverse it. So in fact, they will never be able to communicate with each other if the balloon is expanding too fast. And the analogy is with the expansion of the universe. The ants are light particles of light, photons. So they move at some speed, but if space itself is expanding fast enough, even light cannot bridge the gap that is being opened between us and the friend that is receding from us after some time. So we will be left lonely in the distant future. We will be surrounded by our own Milky Way galaxy, and beyond that, there will be darkness, emptiness. There is a very lonely future for us, which I don't mind. I actually like space. I hate crowded environments. And being here, I was born on a farm, as I told you. I'm very much connected to nature, and I enjoy whatever nature brings to my doorstep. But this is one fundamental question. An even more fundamental question is, are we alone? Is there someone else in our neighborhood? Is there a smarter kid in our cosmic block? Mm-hmm. Now, we tend to think throughout our history, humans thought, we are very privileged. We are the smartest beings on Earth. And guess what? We can put on the menu in restaurants animals that are less smart than we are. We can eat them. That's what we do, right? You go to a restaurant, you can eat a chicken. Mm-hmm. No problem. We don't have any ethical issue with eating animals that are less smart than us. But suppose we encounter an extraterrestrial. If we don't leave a good impression on that extraterrestrial, they might put us in their soup.
Mm-hmm. Well, you might want to think about taking some of that cash and try to protect your purchasing power with precious metals like gold and silver. It's simple. Go to ShawnLikesGold.com or call 855-936-GOLD. You'll learn about top-rated precious metals company Goldco and how they can help you. They're a top-rated company with over 6,000 five-star reviews, tons of awards, and they support this show. And for my listeners, you can get up to a 10% instant match and bonus silver on qualified orders. So if you're worried about your money losing value, or you just want to buy some precious metals that you can physically hold on to, something that's real and been around for thousands of years, Goldco can help. So go to ShawnLikesGold.com or call 855-936-GOLD. That's 855-936-GOLD. Performance may vary. Consult with your tax attorney or financial professional before making an investment decision. This show is sponsored by BetterHelp. I want you to think of a time where you don't think you could be your full self. Kind of like you were hiding behind a mask. October is a season for wearing masks and costumes, but some of us feel like we wear a mask and hide more often than we want to. At work and social settings, around our family. Therapy can help you learn to accept all parts of yourself so you can take off the mask. Because masks should be for Halloween fun, not for our emotions. Therapy is helpful for learning positive coping skills and how to set boundaries, and empowers you to be the best version of yourself It isn't just for those who've experienced major trauma. If you're thinking of starting therapy, give BetterHelp a try. It's entirely online. Designed to be convenient, flexible, and suited to your schedule, just fill out a brief questionnaire to get matched with a licensed therapist and switch therapists at any time for no additional charge. Visit betterhelp.com/SRS today to get 10% off your first month. That's BetterHelp, HELP.com/SRS.
So it's really important to know whether there are others out there. And by the way, we are engaged in conflicts, wars here on Earth. We are led by our politicians to conflicts because here on Earth, everything is zero-sum game. Like there is a certain territory, one nation wants it, another nation wants it. There are 2 wars right now related to that. So it's a zero-sum game. If one side benefits, the other loses. That's what politics is about. But if we find someone out there, first of all, there is unlimited real estate beyond Earth. There is no point in fighting over territory on this rock that we happen to be born on. There is so much out there. We should think about going somewhere else. But moreover, that neighbor that we might find may serve as a better role model for us than our politicians, because it might inspire us to behave better. It might be more intelligent than we are. And the strange thing is, when you bring this up, people say, oh, this is an extraordinary claim that requires extraordinary evidence. It's very unlikely we might be alone. In fact, Elon Musk motivates the idea that SpaceX should bring people to Mars because we have a duty. We might be the only conscious beings in the entire universe. I don't think so. He didn't really search for others. And the whole point is scientific knowledge does not fall into our lap. It requires a lot of work. So Elon Musk said, well, I have all these communication satellites and none of them collided with an unidentified flying object, a UFO. Therefore, I haven't seen any evidence for aliens. That's not the right approach. I actually calculated this week that if you were to consider a meter-sized object, moving around at an altitude of 550 kilometers, where Elon Musk's communication satellites are, it will only collide with one of these 6,000 Starlink satellites in 1,000 years.
Wow.
So this is not really a good measure. And moreover, if there are any functioning devices near Earth, they might be at much lower altitudes. They might be doing something else. They will not collide with communication satellites. In fact, you want to use sensors to look up. And my whole point is that the intelligent thing to do is actually be curious and humble. And we find it really hard. We keep insisting that we are at the center of the universe. If before Nicolaus Copernicus that you mentioned, it was thought that we are at the center, and the church promoted that idea because people feel better if they are at the center of attention. And so then Nicolaus Copernicus was a priest, by the way. I learned it when I went to Poland. He was a priest. He didn't want to rock the boat. And he wanted to help the church. So he realized the church is unable to figure out exactly when Easter is. They have a model where the earth is at the center and everything moves around the earth, and they get Easter wrong by a few days. So he said, well, let's think about it. If we look at all the data and we put the sun in the middle, it actually works quite well. We can figure out when Easter is quite accurately. So he gave the church this model where the sun was in the middle of the solar system, and they said, great, we will use your model, but we will ban your book. The book was forbidden until the 19th century because they said the earth is still, they didn't want to change the public perception. And so they said, in reality, the earth is at the center, but this is a theoretical model that we will use to figure out Easter. And the lesson from this is that, sometimes it's important to rock the boat if the boat is going in the wrong direction. And our boat right now, if you look at politics, at everything, it's not going in the right direction. And I'm trying to rock it. My hope is, if we find evidence for a neighbor, it will change everything, because first we would realize there is someone more accomplished than we are out there. And perhaps, just like finding a smarter student in your class, you can learn from it, And second, it will inspire us to do better, to go to space, to preserve ourselves. We live for less than 120 years, which is 1 part in 100 million of the age of the universe. We live for such a short time, and yet we engage in wars and conflicts that shorten this time that we are on this earth even more. Does that sound intelligent to you?
No.
So my hope is, there are religions talking about Messiah coming to earth, bringing peace and understanding. My hope is that the Messiah will not necessarily come from this earth, that it would come from another star and would give us a better perspective about how to handle ourselves as the human species, to do better, basically. And, maybe I can help bring the message to us. That's really my hope. So these are examples for questions that you asked me. What are some of the existential questions? These two are another thing I wanted to mention is that in 1882, Friedrich Nietzsche, a philosopher, declared God is dead. Okay? And by the way, he belonged to the same nation that killed 6 million Jews a century later. But it also led to the hubris that you find nowadays without spirituality, where science and technology is celebrated, and there is no sense of a purpose other than enjoying yourself, and perhaps finding a superhuman entity out there will bring back the sense of awe that religion did bring, a sense of modesty, humility. You are not the most powerful thing. There is someone else out there. When Moses in the Old Testament, he saw the burning bush that was never consumed. And that convinced Moses that God exists. Nowadays, you can buy online a burning bush that will never be consumed, and it would have impressed Moses. All I'm saying is technology, when it's advanced enough, well beyond what we possess right now, can show up as a miracle, can be very impressive, convince us that there is something much more powerful than us. And this dose of modesty is really needed now.
Very interesting. I want to go all the way back to when we were talking about the universe expanding and the Big Bang. I've heard this so many times, I've watched so many videos, and I'm just, like I said, I am fascinated with this, but how is it that we're able to know that have we found the edge of it?
By the way, just a footnote. I'm in the trenches. I'm doing science. I write a few papers every month. There are some people who publicize science, claim that they are defending science, and if you check their record, they haven't published a single scientific paper over the past decade. It's similar to commentators that are watching a soccer match and telling the players how to pass the ball. I'm one of those players. How dare they, when they criticize me, not doing any science, how dare they represent science? So that's just a side comment. But coming back to your question about the universe, there is no edge. We haven't seen any edge. So again, think about this balloon that is expanding. It has no edge. You can walk around the balloon, but there is no edge to it. And space itself, as far as we can see, all the way to the time of the Big Bang, as far as we can see, the conditions were the same everywhere, to 1 part in 100,000. And moreover, we can also say what lies beyond the region that we can see. The region that we can see is the distance that light traversed since the Big Bang, 13.8 billion years ago. So as I said, we can reverse the movie backwards and we calculate the time that elapsed since the point of that Big Bang singularity. It's 13.8 billion years. And gladly, we see that everything in the universe is younger than that. We haven't seen anything older than 13.8 billion years. So it hangs together. We have a lot of evidence that shows that everything started 13.8 billion years ago. We can even see the radiation that was left from this early hot and dense phase. It's called the cosmic microwave background, discovered by chance in the 1960s. But the point is, everywhere we look, we see that the universe started the same, to 1 part in 100,000. And even beyond the region that we can see, if you go to a distance that is 4,000 times bigger, the conditions must have been the same, because if there was a cliff, if there was an edge, it would have affected what we see.
Okay.
So we can tell that not only that there are 1 trillion galaxies like the Milky Way in the volume that we can see, but also beyond that, if you go 4,000 times farther, conditions must have been the same. And the other thing to keep in mind is, as we go deeper into the universe, we see light that was emitted at an earlier time because it had to make the journey to reach us by now. So we can see actually photographs of the universe when it was younger.
Wow.
I mean, when you look at a mirror, if it's, let's say, a few feet away from you, it just takes a few nanoseconds for the light to cross that distance. So in principle, you are looking at an image that is younger than you are because the light bounced off your face, went to the mirror and back to your eyes some time ago. So you're looking at yourself at a younger...
So you're looking back in time.
Yeah, but if you put the mirror a light year away, then you would see yourself the way you looked 2 years ago because of the time it takes the light to go from your face to the mirror and back. And we can look all the way back to the beginning of the universe, so we can see how the universe looked like earlier. And it all hangs together to an extreme precision at the level of percents. So we have a lot of data by now that is fully consistent with this picture. And the only problem is, if we calculate what will happen in the future, it looks very lonely. We will be left in our own galaxy with the stars that are in the Milky Way. Actually, also the stars of the nearest neighbor, the Andromeda galaxy, will join us within a few billion years. That galaxy is heading on a collision course with the Milky Way. I wrote the first paper calculating what will happen. The night sky will change, because right now the Milky Way is a disk of stars and gas, and our sister galaxy, Andromeda, is similar, but when the two will collide, the stars will mix in their orbits and will make what is called an elliptical galaxy. So the night sky, a few billion years from now, will look very different. The sun will still be around, but we may be tossed away from the center of the combined galaxy, which I termed Milkomeda. But in the very long future, once the universe will age by a factor of 10 or so, all the galaxies that we see will not be visible to us anymore.
So so many questions.
Okay.
If the universe is expanding and everything's moving farther and farther apart from each other, how are we going to collide with another galaxy?
Oh, excellent question. It's just that this Andromeda galaxy was made in a region that was quite dense, and it's not following the cosmic expansion. So you can ask, why aren't atoms expanding with the universe? Or why isn't the solar system expanding with the universe? The answer is that it's held together by a force that is far greater than the repulsive gravity that is causing the accelerated expansion of the universe. So systems that are bound by a strong force, they don't care about the cosmic expansion. You need to go to very large scales of millions of light years before the cosmic expansion rules the behavior of objects. And that's why in the solar system, we don't need to lose any sleep about the expansion.
So when you say the solar system, when you say not the solar system, when you say the universe is expanding,
right,
and that there is no edge,
right,
what is beyond?
We don't know.
So, the farthest we can see is back in time to the beginning of the universe?
To the Big Bang, that's all we can see. And we can infer that conditions are similar to what we see out to a distance at least 4,000 times bigger than what we can see. But beyond that, we have no clue. And
so does that mean the way I thought about this 30 seconds prior to you talking about this was that I envisioned, because I've heard we have multiple universes.
Okay, so here we come to a situation where some scientists are not following the scientific method, in the sense that they are saying, okay, obviously we can't get any data or evidence about what lies beyond the region that we can see, but let's speculate. So maybe there are many other regions of space where conditions are quite different. It's called the multiverse. And maybe anything that can happen will happen an infinite number of times in other places. Now, why is that a good idea for some people? Because if you are a student and you get a D in an exam, then you can say, well, that's not a big deal because there must be another region of the multiverse where I get an A. If anything that can happen will happen an infinite number of times, I shouldn't be distressed about what happens right here, right now. So it takes away responsibility from people. And I have a problem with that because we have no evidence that such regions exist. But it became a very popular idea because if you use quantum mechanics, you can make the case that very early on in the universe, the conditions that we have in our region of space, there could have been many other regions with very different conditions. Because of quantum mechanics, the conditions could have been very different. And as a result of that, anything that could happen will happen an infinite number of times if space is infinite. I have a problem. This is a speculation. Nevertheless, it's popular in the mainstream of theoretical physics. There is another speculation, very popular, that there are extra dimensions, that we live in 3 spatial dimensions and time. But there could be additional spatial dimensions. That's a popular idea. And there is even a whole branch of theoretical physics called string theory that is exploring the implications of that assumption and claiming that perhaps we can unify quantum mechanics and gravity. The only problem is when you ask them to predict what happened before the Big Bang, they say it's too complicated. When you ask string theorists to tell you what lies at the center of a black hole, where again Einstein's theory breaks down, they say it's too complicated. So I ask you, if you have a plumber coming to your home and you say, can you please fix the toilet for me? The plumber says it's too complicated. And then you say, well, would you mind please, I have a leaky pipe in the kitchen. Could you fix that? And the plumber says, no, I can't, this is too complicated as well. But he says, if you look at the metaverse, this thing that you watch when you put goggles on your head, as Mark Zuckerberg asks you to do, if you go there, there I'm a very accomplished plumber. That's pretty much the sense that I get from speaking with string theorists, because they talk about things that I cannot verify. But when I ask them to do a task that will resolve a puzzle in fundamental physics, they say it's too difficult.
String theory is the theory that everything is connected, correct?
Well, no, it's supposed to be the fundamental theory of reality, where quantum mechanics and gravity, two pillars of modern physics, are unified. And the way they are unified is with the use of extra dimensions. I'll tell you a funny story, an anecdote. A year ago, I had breakfast with a string theorist. And I asked him, what was your most important scientific paper? And he said, it's a paper I wrote, and that is a distinguished scholar, a paper I wrote about supersymmetry, which is a new symmetry of nature that was used by string theorists and other theoretical physicists. The only problem is the Large Hadron Collider, which smashes particles at the highest energies at CERN, looked for this symmetry in its natural parameter space and couldn't find evidence for it. So it was ruled out in the original natural parameter space where supersymmetry was supposed to show up when we smash particles at very high energies. So then I tell my friend, I say, well, why would you be proud of a paper for which there is no evidence, and in fact, there was the experiment at CERN that didn't find supersymmetry? And he said, well, because I'm not worried, because maybe if we build a bigger particle collider, we will find that. And that reminded me of the Jewish Orthodox community in Brooklyn, New York, Crown Heights, the Lubavitchers, where they had a theory that their rabbi, once he dies, he will come back as the Messiah. And then he died and didn't come back. So that's a data point, right? You had a theory, now you have data. The theory is not supported by the data. What did they say? We just have to wait. So I ask you, what's the difference between a believer in religion and a believer in physics? The point is, science is supposed to be attentive to evidence. In other words, there are plenty of good ideas that are just not describing reality. And how do we figure it out? We have the guillotine of experiments that chops the head of ideas that are not matching the evidence. So you have to forget about it and move on. But to call your paper successful when experiments disprove that theory is really the wrong attitude.
Very interesting. Very interesting. Back to the universe expansion.
Okay.
So I'm just trying to understand this. And so the way I'm understanding it is, let's say we have a telescope in the center of the U.S. And the telescope cannot see past the borders of the United States.
Okay.
It doesn't mean there's nothing there. It just means, it doesn't mean there's an edge. It doesn't mean...
By the way, the best telescope we have can resolve a human hair from California to Boston.
Wow. Wow.
Can you believe that?
No. But so it doesn't mean that there's nothing there. It just means that we cannot see beyond the border. We don't have the capability to see beyond the border.
Right.
Is that correct?
Yes.
And that's kind of what you're saying.
We are
about
in
the
that situation simply because light did not have enough time to reach us from greater distances.
Okay.
But it's a fundamental limit because, as I said before, now the universe is accelerating. You're actually losing what you already saw in your... So it's as if you're sitting in a room, and as you say, you can't see beyond the walls, but then people are leaving your room. The room is
things
getting
are
emptied.
Leaving the... Okay.
Yeah, so you will even
like
know less.
You're sitting in the middle of the U.S. and let's say you're in Chicago and you're looking at Los Angeles. Eventually, Los Angeles will have expanded so much that you can no longer see. You will not be able
to see what's happening there, and you will not get any updates on social media from any of your friends there.
So the more time that passes, the
less
we're
we
losing.
Yes, we are losing information. Exactly.
Every day we're
And there
losing.
is I wrote a paper about it when the accelerated expansion of the universe was discovered at Harvard, actually. My paper said that the future of astronomy is gloomy. In the distant future, we know less. We will see less. And the question is, like, imagine 1 trillion years from now. By the way, there will be plenty of stars still burning 1 trillion years from now. The most common stars are 1/10 of the mass of the sun, and they live for a few trillion years. Okay, so there's still 1 trillion years is 100 times more than the current age of the universe. So imagine us then, and you will basically see emptiness, darkness around our own galaxy. Why would people believe in the story of the Big Bang at that point? There is nothing beyond our galaxy. And it will become a story being told, just like in religion. You won't be able to find evidence for the radiation that came from the early universe, because by then it would get rarefied so much you wouldn't be able to detect it. So it's really interesting that the origins story of how the universe started will not allow itself to be revealed through looking at the sky if the universe will continue to accelerate its expansion 1 trillion years from now.
Wow. Let's talk about dark energy.
Okay.
So it sounds like that not long ago we thought that there was just empty space.
Right.
There was nothing in there.
Right.
There
Nothing
was
in
nothing
there
in
because-
between the
yeah.
distance.
Right.
Between matter and matter. Now it sounds like we've discovered that there actually is a lot of matter. And is it energy?
Well, mass and energy
In
are the
between.
same, according to Einstein. He basically had this insight that energy equals mass times the speed of light squared, E equal mc squared. And that was demonstrated with atomic bomb. Like a small fraction of mass was converted to a huge amount of energy. And that's how the sun shines. It burns, it fuses hydrogen atoms and makes heavier nuclei. And in the process of doing that, it releases energy. So the sun is losing right now 6 billion tons every second. It's losing mass. 6 billion tons every second in the form of its radiation, mostly radiation coming out, but also the solar wind. There is a wind of particles coming out, and we see it. It shows in a very colorful display in our sky. Just over the past week, there was a geomagnetic storm that showed up as the aurora. These beautiful colors are the interaction of the solar wind with the magnetic field that surrounds Earth. And it creates very energetic particles moving along the field lines, bombarding atoms like oxygen, molecular nitrogen. And these atoms or molecules get excited and they emit the blue, red, and green lights that we see in the sky as an aurora. Mm-hmm. So the sun is losing mass, but it's also losing radiation. And altogether, 6 billion tons of matter. So it's a small fraction of the mass of the sun, but mass is equivalent to energy. And the dark energy is just this constituent that fills the universe, and it makes the vacuum, so it's the same everywhere. And the only effect that it has is on gravity, because usually in any other process other than gravity, all you care about is the energy difference between different states. You transition from one state to another and you care about how much energy that requires or that releases. So if the vacuum has the same energy everywhere, you don't care about it. But gravity says, needs to know how much energy or mass there is per unit volume, and if the vacuum contributes to that, it affects the expansion of the universe. And Einstein at first introduced the vacuum in order to make the universe not expand. At the time when he came up with his theory of gravity, that was November 1915, it was not known that the universe is expanding. So Einstein said, well, it doesn't make sense that the universe started at a specific point in time. It makes more sense that the universe existed forever. So how can I keep the universe forever if I balance the attractive gravity of matter with the repulsive gravity of the vacuum? So he put exactly a perfect balance between the two. But then it was realized a decade later that, in fact, the universe is expanding. So Einstein regretted making that suggestion, thought that it was a mistake. As it turns out, the vacuum does have a mass density. It's just early on, it was not significant at all. So the universe expanded, and then right now it's dominating. So what is it is not known. We don't know whether we can excavate it, whether we can use it, because it's negative gravity, And one thing I thought about, in 1957, there was a British physicist named Herman Bondi, who realized that Einstein's gravity allows for a negative mass in principle. I mean, we know that any mass we see is positive, right? It's attractive. Gravity brings things together. But he said, what if, just like in electromagnetism, you have a positive electric charge and a negative electric charge. So in electromagnetism, positive charges repel each other, and positive and negative charges attract each other. In gravity, positive masses attract each other. But if you were to introduce a negative mass, it will repel the positive mass. So he realized that if you take a positive mass and a negative mass, put them next to each other, the positive mass will attract the negative mass towards it, and the negative mass will push the positive mass away from it. So this pair will accelerate indefinitely. It's like a rocket without a fuel. It will accelerate to the speed of light. He realized that. So if you think, oh, that's great, so maybe we can build a spaceship that has a positive mass and a negative mass. If we can take, let's say, the vacuum energy from the cosmic expansion, if you can engineer it, put it in a vessel, enhance its density, and then we'll get a negative mass. If we can do that and put it next to a positive mass, we'll have a spaceship that doesn't need any fuel and will accelerate as much as we want. The problem is that if you introduce negative masses, this is something that Bondi did not realize. If you introduce a negative mass, you can build a time machine, meaning that you can, in principle, go back in time and kill your grandfather, and that will be a problem. Because if you kill your grandfather, how come you exist? So physicists don't like the idea of time machines because it leads to contradictions. Mm-hmm. And if you have a negative mass, you can build a time machine. How do I know that? Because when you take a positive mass, like the sun, the earth, a positive mass, you pass a light beam next to it, the light is delayed. Time is ticking more slowly near a positive mass. This was realized by a colleague of mine at Harvard named Erwin Shapiro, who is now in his 90s, but he calculated how much delay the light would suffer when it passes near a positive mass, according to Einstein's theory of gravity, and that was measured and verified. Now imagine replacing the positive mass with a negative mass. Instead of delaying the light, you will advance it. It will actually move faster. And that's a problem because once you make light move faster, you can create a time machine because you can then, in principle, visit your past. And if you don't believe that going back in time is possible, then negative masses should not exist in the universe.
How would you go back in time?
So the idea is that, in principle, you can build a time machine using negative masses such that you go next to the negative mass and you come back to your source at an earlier time than you left your source.
Wow.
So that means that so
you'd go out and then back.
And back, and you arrive before you left. And of course, it poses a problem because, as I said, you can prevent yourself from making the trip. And so that there would be a logical inconsistency. There is a lot of debate about whether moving faster than light is possible, whether going back in time is allowed. Most physicists think that it's forbidden because it leads to inconsistencies. And if that's the case, there shouldn't be any negative masses.
You're blowing my mind here, Avi.
This is a paper that I'm writing right now, by the way. It's not out yet. So I'm giving you the latest.
Very interesting. I wanted to talk about, you brought up CERN. What are they doing there? There's a lot
I actually visited CERN.
You visited CERN?
Yeah, because they invited me to give a public lecture just a few months ago. And it was a very fun visit to go through the various experiments that they have there. They smash particles at very high energies. They create antimatter. I was there to discuss extraterrestrials. And it was interesting to see what they are doing. But at dinner, when there were a number of high net worth individuals that came to dinner and sat with me, and out of a group of about a dozen people at dinner, 2 of them said that they saw some unidentified objects, very unusual objects. For example, one of them said that 20 years ago, he saw a giant object in the sky that was moving so fast that it could move faster than fighter jets that were chasing it at the time. Of course, he didn't have any record of that. But what I found interesting is that there are people who saw very unusual things. I never had an experience myself. But as I said, I'm curious, so it raises my interest. And that's what the Galileo Project is all about. We're trying to collect evidence in the scientific way and figure out whether there are things in the sky that we cannot explain. And the point is that, that the sky is not classified. The US government has a day job, which is national security. So obviously they're monitoring the sky, looking for things that may belong to adversarial nations that are spying on the US. But if something came from outside the solar system, that's not part of their day job. That's my day job as an astrophysicist. So if they say that they looked at 99% of the objects, as the All Domain Anomaly Resolution Office is saying right now in the Pentagon, that may be impressive for their own record to say that they understand most of the objects in the US, because from a national security perspective, that's good to know, But from a scientist's point of view, it's not very impressive, because even if 1 in a billion objects that you look at in the sky, and by the way, we looked at 1 million objects already in the last few months with the Galileo Project. We built an observatory that monitors the entire sky all the time. So even if 1 in a billion happens to be from outside of this Earth, it will be a huge message to deliver to humanity that we are not alone. There is something out there. So I'm really interested in the rare objects. Obviously, there is a lot of crap in the sky that we produce, balloons, drones, airplanes. These are boring as far as I'm concerned. If I see a bird, I'll be happy to give all these images to a zoologist. If we see in the Galileo Project, we see Chinese balloons, happy to deliver all this information to Washington. These are boring objects as far as I'm concerned. I just want to see if there is anything else that is not familiar. And, it's a matter of being curious. Why should we have an opinion without seeking the evidence? we should look for the evidence and figure out what's out there. If we find a tennis ball in our backyard, we will know that the neighbor plays tennis.
Great point. Before we get too into the Galileo Project, I am very interested in CERN.
Okay.
There's a lot of conspiracies around CERN. Nobody really seems to know what's going on. You're the first legitimate person that I've talked to that's actually been there.
Ask me anything.
There's a lot of talk about CERN trying to open up some type of a portal. Is there any?
No. If there was, actually the situation right now with the Large Hadron Collider is that aside from finding a prediction made in the 60s to be correct, which was the discovery of the Higgs boson, we haven't...
The discovery of the what?
The Higgs boson. There was a particle that is really fundamental to the standard model of physics. It gives all the particles their masses. And it was realized that such a particle should exist by several independent groups, but one of the original authors of the papers that were written about it back in the 60s, his name was Peter Higgs. He just passed away recently. And so it's called the Higgs boson, as if it's called after him. Initially, his paper was not accepted for publication, and then he wanted, because he just talked about some symmetry, and then he refined it to make it a little more edgy, so that it will be accepted for publication, and mentioned the fact that the model predicts a particle. And now the particle is called the Higgs boson. Boson is a type of particle that actually likes to be in groups of other particles in exactly the same state. For example, the photon is the particle of light is a boson, in the sense that if you put a lot of photons together, they actually enjoy that, in the sense that that's what a laser is. A laser is a lot of photons in exactly the same state, the same frequency, the same phase, and that's why a laser beam is so powerful. But the other type of particles, they are not so social. They are called fermions, after Enrico Fermi. The name bosons is after Bose, Indian physicist. So fermions are particles that do not allow others of their type to be in the same state. So the electron is a fermion, and an electron does not allow another electron to be in the same state, the same energy, the same moment, the same place. And so as a result of that, if you consider a metal, it's basically a lot of electrons packed together in a very cold state, but they don't allow each other to be in the same location. And so as a result of that, if you try to compress a metal, you have resistance to that. And that's why a metal is a solid, very dense state of matter that is not, where compression requires a lot of force. And so at any event, the Higgs boson, it's a boson, was discovered in 2012 by the Large Hadron Collider when it smashed nuclei at very high energy and produced it. So they discovered this particle, and the Nobel Prize was awarded for this discovery. It was very important. It was 50 years after the original conception of this particle. And nevertheless, it was very significant, but it was old news. And a lot of physicists were hoping for something completely new coming from the Large Hadron Collider. But nothing was announced. Nothing was found as of yet. And of course, there are plenty of physicists that would be delighted to get a Nobel Prize for a new discovery of fundamental physics. That's why I don't think anything, it's not like the government. There is a huge incentive for physicists to come forward if they have good evidence. So there is nothing there at the moment.
Thank you for clarifying that. Avi, before we move on, I forgot to do so. Everybody gets a gift that comes on the show.
Thank you. Thank you so much.
We should have done this about an hour ago, but those are Vigilance
Gummy
Elite Gummy
bears.
Bears.
Yeah.
It's a little something for the ride home.
Thank you.
But moving into some of the stuff you're doing right now, I know you are interested in the nearest black hole to Earth.
Right.
Can you tell us a little bit about that and start with what exactly is a black hole?
So a black hole was the first solution to Einstein's equations of gravity. That back then, in 1915, there were no computers. And the equations are very complex. But a German physicist named Karl Schwarzschild, he was 40 years old, the head of the Potsdam Observatory. And he was a patriot, by the way. Einstein was a pacifist. So the First World War started, and Schwarzschild, who was very distinguished, was drafted to the military, went to the front against the Russians. And when he was there, he realized that he can solve Einstein's equations for a point mass. If you take matter and condense it to a point, he could solve the space-time around that. And he sent a postcard to Einstein, who publicized it in Germany, because he didn't participate in the war. And within a few months after that, Schwarzschild died from a rare lung disease, which shows you that being a pacifist is better if you want to derive the consequences of a theory, because Einstein lived much longer. At any event, Schwarzschild is remembered for finding the structure of space-time around a black hole. Now, what does it mean? How can you make such a point mass? One way to think of it is, imagine a star, a very massive star, let's say tens of times the mass of the sun, burning nuclear fuel. A star is just a nuclear reactor held together by gravity. That's it.
Okay.
So, we have a difficult time creating fusion reactors on Earth because confining them is difficult with magnetic fields. But in nature, they appear everywhere. These are the stars. They are confined by gravity. And at the core of a star, the temperature is tens of millions of degrees. And so that nuclear reactor burns the fuel, which is mainly hydrogen left over from the Big Bang. By the way, it was not clear to people that the sun is made mostly of hydrogen. So 100 years ago, the first PhD in astronomy at Harvard University was written by Cecilia Payne-Kopashkin. And she realized that when looking at the surface of the sun, she can infer the composition of the surface and realize that it's mostly probably hydrogen. And she wrote it in her thesis, and then the chair of the thesis committee, Henry Norris Russell, who was the director of the Princeton University Observatory, said, you need to remove that statement because we all know that the sun is made of the same materials as Earth. She removed it. Of course, she wasn't as confident at a young age. And then for 4 years, he checked the data and concluded that she was right. And it's not only the sun, but the entire universe is mostly hydrogen, ordinary matter. That at any event, stars burn hydrogen into heavier elements. That's why we exist, because the Big Bang didn't have heavy elements. It had mostly hydrogen and helium. So life, as we know it, was not possible. We are a byproduct. We were not part of the cosmic plan. By the way, this is something we need to remember, that we arrived late in cosmic history. We arrived late to the play. We are not at the center of stage. So the play is not about us. And if we want to learn more about the cosmic play, we better find other actors who may have been around for longer than us. But coming back to the stars, they burn hydrogen and produce the energy that we see coming out of stars. Now, when a star has more than tens of times the mass of the sun, it has such a strong gravity that when the fuel is consumed, there is no more fuel. Gravity pulls it together and it cannot stop the collapse, and it ends up draining all the mass that made the star into a black hole at the center. So that's one way to make black holes, by massive stars collapsing. Now you ask, okay, what is the final product, the black hole that you get from that? It's empty space because all the mass went to the center, so to speak. But it's an extreme structure of space and time, because Schwarzschild realized if the black hole is not spinning, that there is a certain distance from the center inside of which nothing can escape. It's the ultimate prison. Even if you move at the speed of light, you cannot escape from that region. So think of a black hole as the ultimate prison. And the walls of that prison cell is the so-called event horizon, inside of which everything is hidden. So a black hole is just like Vegas. Whatever happens there stays there.
Okay.
But you can also make a black hole by taking a big cloud of gas and letting it collapse. That's what happens at the centers of galaxies. So just to give you a sense, if you were to fill the orbit of Jupiter around the sun with water, a huge swimming pool, it will make a black hole of about 100 million times the mass of the sun. So the bigger the black hole is, the less dense is the material that can make it. When a star makes a black hole, the density of matter gets higher than the density of an atomic nucleus. But when you make those supermassive black holes at the centers of galaxies, you can make them out of rarefied gas clouds that just contract. Okay. And once you have the seed black hole, it keeps collecting more and more gas from it, just like a drain, that water circles into. The gas in the center of a galaxy is getting consumed by the sink at the center. And you can also have stars. If a star comes close to a black hole that is not too massive, then it will get ripped apart and shredded. And you spaghettify the star, create spaghetti out of it, and the stream of gas. We see those events where stars are getting destroyed by coming close to a black hole that has a mass less than 100 million times the mass of the sun. So that's in a nutshell.
You've actually seen stars be consumed by black holes.
Yes, stars like the sun coming too close to a black hole of less than 100 million times the mass of the sun, and they get ripped apart. And before they enter the event horizon. So then the gas that they leave behind in a stream of debris circles the black hole and creates a flare of radiation. The amazing thing about black holes, even though they are black in the sense that nothing can escape from the inside, when gas is circling the black hole, it's moving at a very high speed, approaching the speed of light. And if the stream of gas intersects itself, or if there is turbulence or viscosity to the gas, then it shines very brightly. So ironically, the brightest sources of light in the universe are actually those supermassive black holes that we see now with the Webb telescope, all the way back in time to when the universe was just a few % of its present age.
Wow.
So these big black holes form very early. And I actually worked out a theory that could explain early formation of those seeds out of very massive stars that form at the centers of galaxies.
Can you see both sides of a black hole? Or is it just one?
Well, it's just a spherical region. You can go around it.
Is it shaped like a donut?
No, it's more like a sphere if it's not spinning.
Okay.
If it's spinning, then it looks like a disk. But the interesting question that has no answer at the moment is what happens to the matter that falls into a black hole? Because Einstein's theory of gravity predicts that it will increase its density, again, indefinitely, just like in the Big Bang, and then the theory breaks down because it can't really tell us what happens. You need a theory that unifies quantum mechanics and gravity to tell us what happens at the center of a black hole. And, I once had a flood in the basement of my home, and I went with a plumber down to the basement, and I realized, actually, I never thought about this. It would appear natural to me that the water is flowing out of my home, but we realized that actually the sewer is clogged by tree roots, okay? And the roots were blocking the sewer, and so the water flooded the basement. So that, in the hours that I was helping the plumber to fix the problem, I thought about a black hole. What happens if there is no portal or sink at the center of a black hole? Because some people say, well, maybe the matter goes there and then exits somewhere else. But no, suppose it's really clogged. So what will happen is that the matter will collect at the maximum density that matter can have, which physicists call the Planck density. So the way I envision that is maybe there is an extremely dense object at the center of a black hole, and it keeps collecting matter that falls into it. We don't know if that is the reality because we don't have a theory of quantum gravity. And there is one way to find out. If you enter a black hole, you might find what happens inside of it, but then you won't be able to submit a paper for publication on Earth because no information can come out. So, when I propose to physicists to enter a black hole and figure out quantum gravity, they think that I have an ulterior motive of sending them into a black hole. But, you may ask, okay, are we at risk that a black hole would ever impact Earth and consume it? Turns out that the nearest black hole to Earth is about 100 light years away, based on how many we expect in the Milky Way galaxy. Not very close to us. There is no risk that it will cross the solar system. But there is a possibility that most of the matter in the universe is black holes. We don't know what most of the matter in the universe is. About 84% of the matter is invisible to us. We call it dark matter. Mm-hmm. We keep saying that we understand the universe, but we don't know most of the matter, and we don't know most of the energy, which is in the form of dark energy or the cosmological constant that I mentioned before. So the dark matter could potentially be tiny black holes left over from the Big Bang that have the masses of asteroids, for example. And if that's the case, there should be many of them crossing the solar system. But the chance of one of them passing through Earth is really small. You wouldn't expect that very often, maybe over billions of years. And in fact, these black holes have a size. Their event horizon is the size of an atomic nucleus. So really tiny. Unless they go through your body, nothing bad will happen. They just go through Earth. They don't affect anything. So maybe the nearest black hole is much closer than we anticipate based on the collapse of stars, which is the 100 light years that I mentioned before. But it will be harmless unless they pass through your body. And the chance for that is completely negligible. I don't think that any insurance companies need to worry about it.
I mean, how would you even, how do we study these?
Black holes?
Yeah, how do we study
Well, we
them?
can see the radiation emitted by the hot gas that is swirling around them. So, for example, I was the founding director of the Black Hole Initiative at Harvard University, and that's a program that brings together physicists, astronomers, mathematicians, and philosophers that are interested in black holes. And one of the accomplishments of that initiative was taking an image of a black hole, which appeared in all major newspapers in 2019. Basically, it's an image of a giant black hole in a nearby galaxy called M87. And what you see is the shadow of the black hole being illuminated by some backlight from the hot gas swirling around it. So you see a ring of light around a dark region. And that's the silhouette of the black hole, because the radiation going into the black hole can never come out. You see it as a dark region surrounded by a ring of light, because the gravity is so strong that it can focus light, just like a lens. This is called gravitational lensing. And that focusing of light creates an image of a bright ring with the silhouette of the black hole in the middle. So we already have that photograph, and we know that black holes are real. This particular black hole is huge. It's about 6 billion times the mass of the sun. Actually getting into it would not be harmful to astronauts. If you cross the event horizon, you wouldn't be torn apart, because it's such a gigantic black hole that the difference in force between your legs and your head is tolerable. It's not a problem at all. The problem starts when you get very close to the center, the singularity, where you will get ripped apart. And I once described this in answer to a question in my daughter's class. And when I got to describe what happens to the human body when it comes very close to the center of a black hole, the teacher stopped me and said, "Please don't continue any farther, because it will create nightmares to the kids." But they were really curious about it. I mean, a black hole is a fascinating thing. It's a structure of space and time empty. And, it's the most extreme realization of Einstein's idea that space and time are curved. Just think about it. Before Einstein, we thought of gravity as being a force. So the sun exerts a force on the Earth that orbits around it. Einstein said, no. All objects follow exactly the same behavior under the influence of gravity. Therefore, it has nothing to do with a force. It's a property of space and time that affects all objects. And he basically made the analogy, just think about a trampoline being the space-time, okay?
Okay.
If you put a very heavy ball in the middle of the trampoline, it curves the surface, right? And so imagine now a marble moving around. So if you give it just the right kick, it will move in a circle around the heavy ball in the curved surface of the trampoline. It will just move in a circle around it. If you now were to remove that heavy ball from the center, the marble will continue on a straight line on the flat surface. And so the same applies to gravity in the context of Einstein, where the space around the sun is curved such that the Earth is trying to go on a straight line, but actually, because of the curvature of space, it's moving in a circle around the sun. And if you remove the sun, the Earth will continue on a straight line indefinitely.
So there's an invisible fabric. It sounds
of space and time. And it's being curved by masses. And in the context of the universe, there is a mass distributed throughout the volume of the universe, and it affects the way it expands.
So if you're saying that we know the universe is expanding, and it's becoming less dense, correct?
Right.
So if it continues to expand and become diluted or less dense, then wouldn't that fabric will that fabric ever stop
Evolving? No, it will
Will it
continue to
become?
evolve.
Will it become? I mean, it sounds like the fabric of space might become weaker as the universe expands. And so, what I'm asking, would that throw planets, Earth, Moon,
No,
out of orbit because
because
it's less dense?
Yeah,
it won't
but
be able to hold.
no, because the thing is that the solar system, the planets orbiting the sun, they are held together by a force, or they're held together by the local conditions that are far stronger than gravity on a very large scale in the universe. So just think about the atom, okay? The electron is bound to a nucleus by the electric force. The electric force is many orders of magnitude larger than gravity. So the fact that the universe is expanding in some way doesn't affect the atom, it stays the same. It's as if you have a leash that you keep the electron tied up to the proton, and you don't let it be part of the cosmic expansion. So the same thing is true for the solar system. It's much denser than the average density of the universe. The average density of the universe is 29 orders of magnitude less than the density of this table. So that means 1 with 29 zeros, less dense. There is roughly 1 atom per cubic meter in terms of the mass density in the universe. Like, it's
One
really
atom
rare.
per cubic meter.
Yeah.
Wow.
That's the average density of the universe. If the universe was denser than that, it would have collapsed back to a point, to an infinite density by now.
So if the universe is
time.
expanding, when will it be 1 atom per 2 cubic meters?
Oh, in the near future, a billion years from now.
And then
So, you just have to be patient. And as I said before, it's not only that things get diluted, but they get diluted exponentially. So as time goes on, they get separated by a speed that gets higher and higher.
do you think that, this is going back, sorry, I have so many questions. When we talk about the universe is expanding and galaxies, planets, stars continue to get farther and farther and apart from each other, and will our technology be able to outpace the expansion of the universe?
Yeah,
will
so
we be
I actually addressed that in a paper that I wrote. How far can we reach, let's say, with propulsion systems, given that the universe is expanding? The point is, right now, all the spacecraft that we launched are moving at 1 part in 10,000 of the speed of light. Since Sputnik to New Horizons, we haven't changed the chemical rocket technology that we used, and it can get us to about 1 part in 10,000 of the speed of light. Unfortunately, with that speed, we cannot escape the Milky Way galaxy. The gravity of the Milky Way is too strong for such rockets to leave the Milky Way galaxy. So that's in a way good news, because anyone in the Milky Way galaxy which is using the same rocket propulsion that we used, if they sent objects to interstellar space, these objects are trapped in the Milky Way galaxy, so they collect like plastics in the ocean. And we can look for those objects in our backyard. So it's a blessing. The fact that rocketry cannot get you faster than the escape speed from the Milky Way is a blessing, because we can then look around us and see all the space trash that other civilizations polluted our environment with over billions of years. Most of the stars formed billions of years before the sun. The sun is a late bloomer, formed only in the last 1/3 of cosmic history. And most other stars formed billions of years before that. It takes less than 1 billion years for Voyager, for example, to go from one side of the Milky Way to the other. Less than 1 billion years. That means that all the space trash that was sent by other civilizations would have reached us by now, if the star that hosted that civilization existed, billions of years before the sun. So we might be swimming in an ocean full of plastics, and we could find evidence for other civilizations. But in order to leave the Milky Way, we need some propulsion scheme that will at least be 10 times or 20 times faster than chemical rockets. It's possible. There are ideas that various scientists are exploring. Even if you use a propulsion scheme that is 100 times faster than chemical rockets, you could only reach a distance that is about 100 million light years from us, which is about 1%, less than 1% of the size of the universe, okay?
Wow.
And that is because by the time you get to that distance, the galaxies that used to be there are now much farther away. So you cannot catch up with the accelerated expansion of the universe. Eventually, you reach your limit. And I calculated that the limit is relatively near us, even if you enhance our propulsion method by a factor of 100. If you reach the speed of light, or a fraction of the speed of light, which is something that I explored because I chaired the Breakthrough Starshot initiative. The idea was to reach the nearest star to the sun within our lifetime. So the nearest star is 4 light years away, Alpha Centauri system that has 3 stars actually in it. In order to reach it within 20 years, we need a spacecraft that moves at 1/5 of the speed of light. And the only method that I could find that might be practical for that is what is called solar sails or light sails. Basically, just think of the sail on a sailboat. It's being pushed by the wind, which is basically air bouncing off that sail and giving it a push. Now imagine making a very thin film and shining light on it. It will also give it a push. So if you take a very powerful laser of 100 gigawatt and shine it off a very thin film, roughly 1 part in 10,000 of the size of your thumb, okay? So a very thin film that we use to wrap sandwiches. And if you take such a film and extend it to a scale of the height of a person and just shine 100 gigawatt of laser on it and make it a reflective surface, within a few minutes, this sail, which weighs roughly a few grams, will be accelerated to 1/5 of the speed of light across a distance that is 5 times the distance to the moon. So that was the concept. Making it practical is a huge endeavor, but it's in principle potentially possible. So if you move at a fraction of the speed of light, then you can reach greater distances beyond the Milky Way galaxy. And if you move very close to the speed of light, you can, in principle, get through most of the volume of the universe. So, by the way, one thing to keep in mind, we are currently experiencing 1g. That's the acceleration that the Earth puts on our body. That's what binds us, gravity, to the Earth. That's comfortable. We feel comfortable in that, right? Now, you would feel as comfortable in a spaceship, a rocket, that is being accelerated at 1g. You couldn't tell the difference, according to Einstein, between a rocket that pushes against your body at 1g and Earth's gravity. You would not be able to tell the difference. Now, if we were sitting on a rocket accelerating at 1g, then in 1 year, we would reach the speed of light. 1 year. If you were to continue to accelerate at 1g for about 20 years, you will get so close to the speed of light that time would pass much more slowly in our frame than in the rest of the universe. So we would be able to actually cross the entire scale of the visible universe, billions of light years, in 20 years, on the spacecraft, at 1G. Whereas, obviously, everyone would die on Earth during that journey. If we come back, we would not find it. I mean, the sun, if we continue over 7 billion years and we come back, the sun would already burn its nuclear fuel, become a giant, what is called a red giant, would engulf the Earth. There will be nothing left. The Earth would be burned up and eventually spiral into the center of the sun. And the core of the sun will become a dense body that is basically like a piece of metal, the size of Earth, carrying about 60% of the mass of the sun. That is called a white dwarf. So if we made that journey and came back, our home will look very different than we left it. But it's an amazing thought experiment to think that if you accelerate at 1G, which is very comfortable for us, we can reach very close to the speed of light and cross the entire universe in our lifetime.
Very interesting. Very interesting. Let's take a quick break.
Okay.
When we come back, we'll get into some extraterrestrial stuff. Did you know that only 4 companies own over 80% of the U.S. meat industry? And reports say that China owns the largest portion of the pork industry in the U.S. These companies seem like they are using tactics to try to crush American family farms with the additives they're putting into our food. Americans are stuck with sketchy meat, so what can we do about it? Let me tell you about a company that's coming up swinging on behalf of the American family farm and your family's food security. Moink. The business is simple. Moink's meat comes from animals raised outdoors, and their farmers are given an honest day's pay for an honest day's work. They deliver meat straight to your doorstep at prices you can actually afford. Born, raised, and harvested right here in the United States of America. Keep American family farms farming by joining the Moink movement today at moinkbox.com/SRS. Sign up today and get free hot rolls in your first order. Spelled Moink, M-O-I-N-K box.com/SRS. Oink, oink, get moinked. Moinkbox.com/SRS. Managing your personal finances can seem very complicated and it's very time consuming, right? But it doesn't have to be. Check out Rocket Money. Rocket Money simplifies everything, making it so easy to see exactly what's happening with your finances, track your spending, and give you full control of all of it right from your phone. Rocket Money is a personal finance app that helps find and cancel your unwanted subscriptions, monitors your spending, and helps lower your bills so you can grow your savings. See all of your subscriptions in one place and know exactly where your money is going. Need to clean up your subscriptions? Rocket Money can help you cancel them with a few taps. Rocket Money's dashboard gives you a clear view of your expenses across all of your accounts. You can easily create a personalized budget with custom categories to help keep your spending on track. Rocket Money has over 5 million users and has saved a total of $500 million in canceled subscriptions, saving members up to $740 a year when using all of the app's features. Stop wasting money on things you don't use. Cancel your unwanted subscriptions by going to rocketmoney.com/Shawn. That's rocketmoney.com/Shawn, rocketmoney.com/Shawn. All right, Avi, we're back from the break, and we're going to get into some extraterrestrial stuff in the Galileo Project, but we'd started having a pretty interesting conversation at breakfast about if we think that the U.S. government is hiding any type of evidence when it comes to UFO, UAP, extraterrestrial life phenomena type stuff. So I had said yes, I do believe they're hiding something. I don't have any hard evidence, but I just don't trust the government. So they've lied one too many times, and I didn't want to get your answer at breakfast. I wanted to wait until the interview. So I'm curious what your thoughts are on that.
Well, astronomers are focusing on very distant sources of light, and usually a small portion of the sky. And if something flies overhead, they ignore it. However, the US government has to monitor the entire sky and look for unusual objects because they might represent adversarial nations that are spying on the US. So while doing so, they might have noticed things that are unusual. And I don't expect the US government to figure things out if they are not made by humans, because they are not a scientific organization. They are dealing with national security. So the only question is whether they provided unusual materials, unusual evidence to corporations outside Washington, D.C., whether they classified such information in a way that even within government, most people are not aware of it. And until I see the evidence, I cannot tell from the outside, because you get conflicting reports, and because there is also an effort to create some buzz in the public about unidentified objects, because the US government develops new technologies. And if people use their cell phones to record something unusual, they might realize what the US government is doing, and therefore there is an interest on behalf of the intelligence agencies to create some buzz about extraterrestrial objects so that people will not be suspicious of the US doing things. That I can understand. I can also imagine a motivation to create some confusion in other countries about what the US is capable of. And so given all the dust that is thrown up, it's really difficult to see anything specific. And I spoke for an hour with David Grush, who testified in the US Congress under oath, and asked him to mention anything I don't already know from the public domain. And he said that he's unable to speak about it. And without that evidence, I really have no way of believing a story, because there may be other reasons for the story to be told. And as a scientist, I realize that the sky is not classified, the oceans are not classified. Why should I wait for the government to tell me what lies outside the solar system? And so I am leading the Galileo Project, which is trying to collect evidence. And, for 70 years, we've been searching for radio signals from other civilizations. When radio communication was used on Earth, scientists realized, well, maybe we can look for signals from other civilizations. But first of all, this is relatively early in our technological development. We don't use radio communication as much nowadays. And moreover, if you were to transmit signals, you are vulnerable to predators in interstellar space. And so it's not clear at all that such signals will be abundant. And we haven't found anything. It's just like waiting for a phone call at home. And, nobody may recognize that you're lonely. And moreover, if other civilizations are addicted to their digital screens, the way we are right now, they wouldn't care about us. So there is an alternative way, which is to look for space trash, objects that came from our neighbors' yards, and find them near us, because they are bound to the Milky Way galaxy. They keep accumulating over time like plastics in the ocean, and we can search for them. And if we find an object like Voyager 1, Voyager 2, Pioneer 10, Pioneer 11, New Horizons, the 5 interstellar probes that we are trashing interstellar space with, that will tell us that someone like us existed elsewhere. And by the way, most of the scientific community, the astronomy community, is interested in finding evidence for microbial life, primitive life. Because when the Earth cooled 4 billion years ago, microbes immediately emerged. But the signature that they leave, that we can pick up at a distance, is very subtle. They produce some molecules that we can search for in the atmospheres of planets as they orbit their star. So we can look for the fingerprints of these molecules like oxygen, methane, carbon dioxide, water vapor, and say, well, if we find these molecules, maybe they are indicative of microbial life. This is where the astronomy community wishes to put its funding in terms of the search for extraterrestrial life. And I say, well, if we were to find a gadget that was sent by another civilization, that would be conclusive. It wouldn't be subtle, because these molecular fingerprints can be also produced by natural processes. You can imagine processes that have nothing to do with life, that make oxygen, methane, and these could be processes that have to do with geology, with just natural chemistry. So it will be debated, even if you invest tens of billions of dollars in finding those fingerprints in the atmospheres of planets that transit in front of their star, and the light from the star goes through the atmosphere of the planet. Even then, if you find it, it will still be debated whether they mean that there is microbial life or not. And I say, if you find a gadget, there is no debate. If it's not produced by humans, it represents technologies beyond what we possess. If you find industrial pollution in the same atmospheres of other planets, you will have evidence for molecules that are not produced by nature, just like CFCs that our refrigerating systems are producing. It's clear. It's a clear signature of technology. So we could look for that. We could look for city lights on the night side of planets. These are things that, if we find, would tell us that not only there is life elsewhere, but it's intelligent. And that's why I think that focusing all our attention on microbial life doesn't make sense. We need to hedge our bets and invest at least as much funding in the search for technological life elsewhere. And my approach is to look for objects. This is something that was never attempted before the last decade, because only over the past decade we discovered the first objects from outside the solar system in the form of the interstellar object that was the size of a football field, Oumuamua, discovered by a telescope in Hawaii and in 2017, and it had very strange properties. It was changing its brightness. The reflection of sunlight from it changed by a factor of 10 as it was tumbling every 8 hours. And modeling these variations implied that it was flat, pancake-like. And moreover, this object was pushed away from the sun by some mysterious force without shedding any of its mass. It didn't have a cometary tail the way comets have. So it was not the rocket effect which was pushing it. And I said, well, based on my research, maybe it's a very thin membrane, a very thin film pushed by reflecting sunlight, like a solar sail, or maybe a surface layer of
like what you were describing earlier.
Yes. So I just wrote a paper saying this object is so weird that it could be technological in origin.
Where is the object now?
Now the object is much farther away, a few times the distance between the Earth and the Sun, but it's actually 1 billion times fainter because it got so far away from the Sun. And so we cannot really see it. We cannot chase it because it's running away from us faster than our best rockets. And so the only way to figure out what such an object might have been is to find more of the same. And actually in 2025, there will be a new observatory monitoring the sky, serving the sky in Chile called the Rubin Observatory, funded by the National Science Foundation. It will employ a camera that is 1.2 meters in diameter, significant fraction of the size of a person, and will have 3.2 billion pixels, 1,000 times more pixels than your cell phone camera. It will survey the southern sky every 4 days, the entire sky. And our calculations imply that every few months it should find an object like Oumuamua. So obviously when we see the next weird object from interstellar space, we can tell, because if it's moving too fast to be bound by gravity to the sun, we know that it came from outside the solar system. That's what Oumuamua did. And Oumuamua means a scout in the Hawaiian language. That's where the name came from. But hopefully we'll find many more scouts like it, and then we can study them in great detail. For example, now we have the Webb telescope, and it's about 1 million miles away from Earth. So if we look at the same object from Earth and the Webb telescope, we will see it from different directions. Just like having two eyes, it will allow us to infer the exact location of this object, the distance to the object. And we could also detect the heat that it emits in the infrared with the Webb telescope. We can tell the size of the object, the reflectance of sunlight. We will learn much more about such an object given that we have the Webb telescope. So altogether, within a year, my hope is we will find many more objects like Oumuamua. But even before Oumuamua, 4 years earlier, there was a meteor, an object the size of a watermelon, 0.5 meter or so, or bigger, that collided with Earth and burned up in the lower atmosphere. And it was detected by US government satellites that are monitoring the Earth for ballistic missiles. Every now and then they notice a collision between an object from space with Earth, because they see the fireball. This collision released a few percent of the Hiroshima atomic bomb energy. And once the Department of Defense realized that it's an astronomical object, not related to any warfare here on Earth, they released the data in a catalog that NASA put out. And together with my student, Amir Siraj, we realized that this object was unbound to the sun, that it came from outside the solar system. So it was actually the first interstellar object before Oumuamua, almost 4 years, discovered on January 8th, 2014. And it also looked weird because it was moving faster than 95% of the stars near the sun. And also it exhibited material strength that is tougher than iron meteorites. So it was tougher than iron. It only disintegrated when it reached the very dense lower atmosphere of the Earth. It exploded about 20 kilometers over the Pacific Ocean. And the US Space Command confirmed that this object was indeed interstellar, that it was moving too fast to be bound to the sun. And I reached out to them because my colleagues were saying, we don't believe the US government. And I reached, as chair of the board on physics and astronomy, I reached through the White House, and the US Space Command issued a letter submitted to NASA to confirm that this is indeed an interstellar meteor, the first recognized interstellar meteor. And there was another object that was discovered in 2019 from interstellar space that happened to be a comet, a regular comet, the way we see comets in the solar system. They're basically a rock covered with water ice that gets evaporated when it comes close to the sun. And people ask me, okay, well, this one, which is named Borisov, this comet is familiar. It's natural. We know about comets. So doesn't it convince you, they ask me, that Oumuamua was also natural and not artificial, not technological? And I said, well, if you go down the street and you see a weird person, and after that you see a normal person, it doesn't make the weird person normal. So Oumuamua was still quite unusual. And so this entire field of study of looking for objects that came into the solar system from outside and figuring out whether among the rocks that look familiar, there might be some space trash from extraterrestrials. That was never pursued before. And that is my current focus. I'm trying to figure out if any of these objects might have been technological in origin.
Very, very interesting. And when it comes to, I mean, you say that the universe is 13.8 billion years. And humans have been around for how long?
A few million years. Just one part in 10,000 or so.
So, kind of what I'm getting at is, I had this conversation, it may have been Tim Gallaudet, but whoever it was, we were talking about what are the chances that humanity as we know it lines up on the same timeline as other extraterrestrial life. Maybe we are the only ones in the universe
right now
at this time.
Yes.
And I've been thinking about that ever since we had that conversation. But now, when you're telling me that we can see back to the beginning of the universe, it sounds like there's nothing that we couldn't collect over the 13.8 billion years with the technology that we have.
And also that the Milky Way is like a wastebasket that collected all the space trash over the billions of years that elapsed since the first stars formed. And, we can look into this wastebasket and check if someone existed before us. They don't need to live right now with us. And so it's a completely different approach to searching for others that may have existed billions of years ago, left behind some monuments, some space trash that we can find.
Wow.
And now the key question is whether any of the objects that comes close to Earth is still functional. Because our own Voyager, for example, will not be functional once it leaves the solar system to interstellar space. When it exits from the Oort cloud, the outer boundary of the solar system, it will not be functional in 10,000 years. So it will be just space trash. But you can imagine a more advanced civilization, because we had only 1 century of science and technology. But if another civilization, had science and technology for thousands of years, maybe 1 million years, they could have sent probes that would survive the journey and would still be around in now, billions of years after they were made. And the question is, are they around us? Is there any evidence? Because the Director of National Intelligence submitted 3 reports to the US Congress about unidentified anomalous phenomena. And if you think about it, these reports, if you don't believe that there are any extraterrestrial objects that these reports are describing, then it's the intelligence agencies admitting that they're not doing their job. Because if it's all made by humans and they cannot figure out the nature of these objects, either they should get a pay cut or a boost in their funding so that, people should get alarmed that there are objects flying in the sky that we don't understand. And indeed, there was this Chinese spy balloon that was shut down. Maybe there are many more that we haven't realized. My point is that it's a question that should be addressed using the scientific method by collecting data, and we should figure out if humans are sending these anomalous objects that the government is unable to identify. I was actually at the Washington National Cathedral in the company of Avril Haines, the Director of National Intelligence, after she submitted the first report. And since she has a bachelor's degree from the University of Chicago in physics, we speak the same language. And I asked her, what do you make of these objects? And she said, I don't know. And then Jeff Bezos went to the stage and talked about the fact that he was inspired to create Blue Origins after watching Star Trek as a kid. And I said to Avril, I never liked science fiction because it involves fiction. And I cannot enjoy it because it violates the laws of physics. The storyline, it doesn't make any sense. And she said, Avi, we have to work on you. So, and it was interesting that I was invited, the first scientist to be invited to this Munich security conference where heads of state and other important politicians come together every year. And when we went to have a drink on the roof of the hotel, I could see snipers with black head covers on the roof. And I realized they're not here to protect me. They're here to protect Volodymyr Zelensky, for example. And I then realized that indeed being a politician is far more controversial than being a scientist. So I'm in the right business. I'm just trying to figure out the world,
What do you make of some of these? I mean, I know you did Ryan Graves' podcast.
Right.
And David Fravor. I think I'm saying his name right.
Fravor, yeah.
Fravor, excuse me. But, these underwater UAPs, just all of the UAP, UFO phenomena type stuff that we're catching on camera. What do you make of this stuff?
Well, we need better data. The data that is available is not good enough because we don't know the distances to those objects. Just to give you an example, suppose you are in a highway and you see a black car behind you. And then you look forward and you see a black car in front of you. And then you say, wow, that's amazing. This black car was moving really fast. I didn't even notice when I looked at the rear view mirror. I didn't really notice the car passing. But it could be that it's not the same car. And so if you have a swarm of objects that come in and out of view, you might think that they're moving really fast, but it's not the same object. So what we need is really much better data. And unfortunately, as we discussed before, the US government classifies most of the interesting data. They release data which is not as convincing. Mm-hmm. And the fundamental question is, are they hiding something of great scientific interest? I would not exclude that possibility, but waiting for them to release classified information is like waiting for Godot, the play of Samuel Beckett. You can wait forever. And that's not a good approach because we live a short life. I want to know the answer. If they do have the information, I beg them to release it because otherwise I'll waste 20 years of my life, the remaining part of my active life, looking for the answer when they already have the answer. So I really hope that they would share it because anything that lies beyond the solar system, it's not a matter of national security. From a large distance, you can't really tell that the Earth is split into nations. When you look at the Earth from the moon, mm-hmm. you don't see the border between Russia and Ukraine. And so it makes zero sense to maintain such information confidential. It's as if you were the President of the United States were to decide that indeed the sun is made of hydrogen, but we shouldn't let the public know about it. And hiding information from the public on scientific matters makes no sense because eventually it will come to light. And the way I approach it is in the scientific way, that I don't care about anything that may have national security implications. That's what the government should do. But if there is 1 in a billion objects that came from outside of this Earth, we should know about it. And with the Galileo Project, we developed a new brand of observatories. We have one operating right now at Harvard University. Over the past few months, we looked at 500,000 objects. It's looking at the entire sky in the infrared, in the optical, in the radio, and in audio. And then we have machine learning software trying to figure out whether we are looking at a bird, a drone, a balloon, an airplane. So far, we haven't seen anything anomalous, but it's one location near Boston. And we are assembling a copy of that observatory in Colorado.
How were these locations chosen?
Well, the Harvard location was just a test place. We wanted to be able to test the instruments that we have, calibrate them, see that they perform to our satisfaction. The Colorado one was for a change in place, but it potentially could be moved elsewhere. And then we have a third one that was just funded by the Richard King Mellon Foundation at $575,000. And we will assemble a third observatory in Pennsylvania because they paid for it to be there. In principle, we can build an observatory for $500,000 in any location. So it's just a matter of funding. And my hope is that we will have tens of them and we will record billions of objects over several decades. So we will get to the bottom of the question of whether there are objects in our sky that are not from this earth. Okay, we will know. Whether anything happened in the distant past, like 50 years ago, will be very difficult for us to tell, because if events are very rare, that they happen once per century, once per half century, then we might not be lucky to be at the right place at the right time to see them. But what is important is that military personnel, when they report about an unidentified anomalous phenomena, they happen to be at the right place at the right time. But that is an anecdotal report. They don't sit there for a long period of time looking at the entire sky. And so what we are doing allows us to calibrate the noise from the background so that if something unusual shows up, we can say how unusual it is. And this is one branch of the Galileo Project. A second branch is to search for unusual interstellar objects using the data that comes from the Rubin Observatory in a year, that will monitor the southern sky every 4 days, and we'll have the sensitivity to find objects like Oumuamua.
Is this the one in Chile?
In Chile.
How was that location chosen?
That was the National Science Foundation. That's a very good location for telescopes because the visibility is great. Chile has this set of mountains where the best telescopes in the world they operate. So it was chosen for that reason.
Okay.
It's very good for astronomy. And we hope to use the data coming from that observatory to find more objects that are interstellar in origin and look as weird as Oumuamua, so we can figure out whether any of them might be technological in origin. Okay? And then there is the third branch of the Galileo Project that I'm most excited about, and that is looking for the materials of interstellar meteors. So, for example, the one discovered in 2014 by the US government satellites exploded about 70 miles away from the coast of Papua New Guinea in the Pacific Ocean. So once the US government confirmed, the Department of Defense confirmed the location and the velocity of this meteor, I decided to lead an expedition to search for the materials, the remains of that meteor at the bottom of the ocean. And just to explain, we're talking about the floor being at a depth of a mile across a region that is 7 miles in width.
Wow.
And that is the fireball location that was publicly disclosed by the US Space Command. And so we went there. This expedition cost $1.5 million. There were about 30 people with me on a ship that was fittingly called Silver Star. And we used a sled that had magnets on both sides and placed it on the ocean floor and dragged the sled back and forth 26 times across that region. And it's just like mowing the lawn. Except the first challenge was to keep the sled on the ocean floor because it would very often kite by the tension in the cable that connected it to the ship. The length of the cable was about 3 miles. And we would just skim the ocean floor and eventually bring the sled to the deck of the ship and collect all the materials on the magnets. And I was the chief scientist on this expedition, and they would wake me up in the middle of the night. I didn't sleep much. I wrote 43 diary reports on this expedition and put them on medium.com, and that's where I post essays every day or two. And they were read by millions of people around the world, translated to Spanish. People were fascinated by the way science is done, which is collecting materials and analyzing them to figure out the origin of this object. There was even a person in Denmark that emailed me when I was on the ship to tell me that he had a stroke, and reading about the expedition gave him the will to live. For me, that was the most rewarding message that I got, because, just being curious and following the method of science appears to be rare. You ask yourself, why? Well, the reason is because in academia, a lot of people are driven by the wish to show off. They want to demonstrate that they are smart, so they get honors, awards. And the way to do that is not to make mistakes, not to take risks, not to be too curious. Because if you are too curious, you sometimes make mistakes. Like a kid, you explore things, you harm yourself, you don't do the right thing, you make mistakes along the way. And so, even though these people started as kids, they lost the curiosity when they became adults. And if you think about it, the whole idea of tenure in academia that gives you the freedom to pursue your curiosity, to pursue things that are not popular at the time, to give you job security, is being abused by people who are using it to just empower themselves. And so common sense is not common in academia. And when I went to the expedition, a lot of scientists, I wouldn't say a lot, but a few of them were arguing that I will not find anything and that they don't believe the US government. We went there, we found materials. We found molten droplets in the site of the fireball from this meteor. And we brought the materials back. I gave them to my colleague at Harvard University, a well-renowned geochemist named Stein Jacobson. And over 9 months, he used the best instruments in the world to analyze them. And we realized that the chemical composition of 10% of the molten droplets that we brought back was different than materials from the solar system that was previously reported in the scientific literature. So we believe, material that may have come from outside the solar system, but the droplets that we discovered were less than a millimeter in size. They were the size of a grain of sand.
Wow.
But they looked very distinct from sand because they looked like metallic marbles. And when I took photographs of them on the ship and wrote some medium reports about them, my daughter saw the images and she said, Dad, they look so beautiful because they look like metallic marbles. And she said, could you put one of them on a necklace so that I can wear it? And I said, well, these are less than a millimeter in size. They're made mostly of iron. You can't thread them. But they look beautiful. And the hope is that we can find bigger pieces. So we are now planning the next expedition, hopefully within a year. It will cost $6.5 million, much more, 4 times more than the previous one. And we will be looking for bigger pieces, perhaps even the wreckage of the core of the object that collided with Earth. And for that, we want to use a remotely operated vehicle, a ROV, that we put on the ocean floor and have a video feed so we can see the pieces that we are picking up. That's why it's more expensive. And we are now seeking the funding for this expedition, and hopefully we'll get it soon so that we can start to build the tools that we will use.
What did your colleague find from the samples?
We found a chemical composition that looked very different than the crust of the Earth, Mars, the Moon, asteroids. So it looks as if it's material that came from another star. To figure it out better, we really need bigger pieces, because what happened is these molten droplets lost some of the elements that made them in the explosion. These are called volatile elements that can evaporate and be lost during the explosion. But if we find bigger pieces, they retained all the elements that made the object. Also, we can tell what the object was like. We can tell the difference between a rock and a technological gadget. Just imagine a computer. If you were to burn it up and melt it, you would find droplets left over. So it would tell you that the composition was unusual, but it will not tell you what the original object was. However, if you find a big piece of the screen, then you would realize that it's not a rock. And so if we find a gadget at the bottom of the ocean, and it has, for example, buttons on it, the fundamental question is, should we press a button? And I asked my students, in my class, what do you think I should do? And half of them said, please don't do that. Don't press a button because it will affect all of us. And then the other half of the class said, please do, because we are really curious to know whether, maybe it's ChatGPT 100, it will do some amazing things. And then one student raised his hand and said, well, given the split vote, what would you actually do, Professor Loeb? And I said, I will take it to a laboratory and study it, examine it, before engaging with it. So don't worry. However, we didn't find a gadget as of yet. If the US government has such a thing, I want to see it.
So there were elements that we've never seen before.
Well, we've seen the elements because the tools that we use to analyze the material, they're looking for elements from the periodic table. They're not looking for something outside the periodic table. So we look for elements that are familiar, but the concentration, the abundance of those elements was very different than you find in the crust of the Earth or on Mars or in asteroids. So it's just like ingredients of a cake. It's how much sugar you put compared to flour and so forth. And we found that the ingredients have very different concentrations than in solar system materials.
Interesting.
By up to a factor of 1,000. These were elements like beryllium, lanthanum, and uranium. So we had to invent a name for this material, and we called it Belau for these three elements.
I just saw this thing the other day where it sounds like, and this could be social media garbage for all I know, but supposedly we have found another planet with water.
Oh yeah, water we know exists in many places, but it's not a guarantee for life. And moreover, what we usually find is water vapor in the gas phase. What we want to know is whether liquid water exists on another planet, because the chemistry of life as we know it happens in liquid water.
I think they were saying this was liquid water and with an atmosphere.
There was a possibility of explaining the size of the planet given its mass if it has a large ocean, water ocean. So that is indirect evidence. to have liquid water on a planet, you need an atmosphere, because if you take solid ice, water ice, and warm it up in vacuum, it just goes straight into gas, into vapor. It doesn't go through liquid. The only way to get liquid water is if there is external pressure from an atmosphere. And to maintain an atmosphere, you need a massive planet like the Earth. So when you see comets, they carry water, ice, but when they come close to the sun and they get warmed up, the water turns into gas, and there is no liquid water on the surface of comets. And so the only other object in the solar system that has liquids on its surface is a moon of Saturn. It's called Titan. And that liquid is methane and ethane. It's very different than water. So there are two objects in the solar system that have liquids on the surface. The Earth has water, and Titan has oceans and rivers and lakes of methane and ethane. And the temperature on the surface of Titan is just 90 degrees above absolute zero. So it's about a third of the temperature of Earth above absolute zero. So it's very cold, but these liquids exist because they're methane and ethane. And what I would like to do if I had the opportunity is to go fishing there, to look for fish. Because if we find fish in those oceans of methane and ethane on Titan, it would mean that there is life as we don't know it. You know, we are often searching for life as we know it, but there could be other forms of life. And an interesting place to visit is Titan. And actually in 2028, NASA will launch probes to Titan. The project is called Dragonfly. And we might know more about whether life exists in Titan. I was interested in that for another reason, because the temperature on the surface of Titan was the temperature in the entire universe when it was roughly 100 million years old. So it was hotter early on, the universe, and then it cooled as it expanded. So the radiation that fills up the universe right now is only 3 degrees, 2.726 degrees above absolute zero. So it's freezing. But when you go back in time to when the universe was just a tenth of a percent, to a time when the universe was 1% of its current age, the temperature was the same as the surface temperature of Titan. So that means that if you had moons or planets with ethane and methane on the surface, they could have been warmed up enough just by the cosmic radiation. They don't need to be close to a star like the sun. And so life could have existed everywhere, very early, if we find life on the surface of Titan, as we don't know it. And I'm very much looking forward within 4 years to learning whether there is life on Titan, because it would say something about how early life started in the universe.
Wow. Wow. How interested, when you've, the disc-like object, what did you call that?
Oumuamua.
Oumuamua.
Yes.
That, the meteor that you recovered pieces of, how much interest is the government showing in your work?
The government supported my research so far. There was they had no issue. In fact, the U.S. Space Command, under the Department of Defense, sent a letter to NASA confirming the interstellar origin of the meteor. And so I'm grateful that they provided the confirmation and the data about this meteor that allowed us to search for the remains of that meteor. And there is another meteor that we identified as potentially being interstellar. It was discovered in March 2017, and I asked the government to verify whether it was indeed interstellar, and if they do, then we will go after that as well.
Are you worried the government is going to interfere with your studies if you...
So far, they haven't, so I'm not worried. There were visits to my home, for example, by the director of AARO, the All Domain Anomaly Resolution Office, who by now left his job, Shawn Kirkpatrick, and his team. They asked questions about the Galileo Project, but I think it was just for them to figure out what we are doing. And I have nothing to hide. It's a scientific project.
What do you think of some of the research that's... Have you heard of Skinwalker Ranch?
Yes.
What do you think of some of the research that's going on there?
Well, the problem with that place is that the location is known. So you can imagine hackers planting evidence that appears weird. And that's the issue I have, because you never know if people are trying to trick you. And it's best to operate without people knowing exactly where the surveys
I've
do.
not thought of that. Thought of that.
Yeah.
Do you think there is any sort of... I mean, a lot of people think this is some sort of... Maybe some of the phenomena stuff that we're seeing is some type of a spiritual entity. What are your thoughts on that?
I don't think so. I mean, I don't think it's a smart thing to associate physical objects with spirituality, because the way I think about our brain is the same way I think about artificial intelligence. Natural intelligence and artificial intelligence, may become similar, or we might be able to better understand the human brain by generating AI systems that are as complex, they have as many connections as the number of synapses in the human brain. We are getting there. And at that point, the system is so complex that it behaves in ways that we cannot forecast. And as a result, it looks as if it has a sense of independence, consciousness, or a spiritual component to it, simply because we can't figure it out. As I mentioned, Moses felt that the burning bush that was never consumed has a spiritual significance, right? And today you can buy online a gadget that would have given Moses the same sense of awe. And so if we are able to reproduce or even create machines that operate better than the human brain in terms of how complex they are, it would imply that what we call spirituality is just an emergent phenomena out of complex systems. Okay, and so I don't think we should imagine that a system that is unpredictable to us must have a sense of free will necessarily. I think it's just that it has so many degrees of freedom that it can't really operate in a predictable way. It's affected by its environment. It's affected by quantum mechanics that introduces some uncertainty. So altogether, it gives us the impression that there is something beyond the physical reality, but it's simply our ignorance of understanding the details of that complex entity. And, if we find a functioning device from extraterrestrials, it may well be equipped with artificial intelligence, and might be difficult for us to figure out. In fact, if we find such a thing, I wouldn't want to rely on physicists telling us what it's doing, because physicists are not used to dealing with intelligent systems. I would hire psychologists. Psychologists deal with intelligent systems. These are humans, right? And they would be better equipped to figure out the intent of an AI system that came from outside of this earth. I would also use our own AI systems, because they might have affinity to extraterrestrial AI systems more than to us, if they are built of the same materials.
Wow. Very interesting.
By the way, the
Very
whole
interesting.
subject of AI, we have to realize that the first time we meet aliens might be when we deal with AI, which are our technological kids. I have two daughters, and I don't always understand them, right? And so I have no problem with the fact that they might be smarter than I am. But the same could apply to our technological kids. You know, AI systems might outsmart us, we won't figure it out. And this will be our first encounter with an entity that is smarter than us, because until now we thought that we are the smartest here on Earth. And it will be a good preparation for an encounter with a more intelligent neighbor. And maybe that gadget that will be functional that we would encounter would have in it AI, because if you think about interstellar travel, the trip takes a long time. Even at the speed of light, it takes tens of thousands of years to cross the Milky Way galaxy. And that means that biological creatures like us will not survive the journey. There are cosmic rays that would damage our body. But you can imagine hardening a technological system to survive the journey and having an AI guide it so that it's independent, doesn't wait for guidance from the sender. So the situation is similar to helicopter parenting. This is the approach we took with all the gadgets we sent to Mars, for example. They are operated by engineers at the Jet Propulsion Lab in Pasadena. However, and we even operated a helicopter on Mars. So that's why helicopter parenting is really appropriate here. But eventually, when we go to greater distances, and it may start with Titan, we want our probes to have their own intelligence so that they make decisions on the spot. It takes a long time for the signal to go back and forth from Earth to the probe. And so it's just like sending our kids out of home. You don't expect your kid to call you for any decision, only to report back when something important happens and send you a postcard or call you. And therefore, using AI for space exploration would be ideal when you go large distances, because then you send autonomous systems that can operate on their own based on the guidelines that we gave them. And they can communicate back the most important information to us. As of now, we haven't sent AI to space. But to me, it sounds like the wave of the future.
Have there been any other signs of extraterrestrial life that we haven't talked about yet, that you're aware of?
We talked about radio signals, the search for molecular fingerprints in the atmospheres of planets, which is a primitive life in the form of microbes, and objects that may have arrived near Earth, and other technological signatures like industrial pollution, city lights. So these are all subjects I worked on, but we covered all of them.
When you were talking about the observatory that's going to be in Chile, I can't remember the year.
2025. In
2025.
Yeah.
You had mentioned that you thought that we would see objects like the disk, maybe one every couple of months.
Yes.
Why? What makes you certain with that prediction?
Given that we found one object over a period of time of a few years at that distance, and with a telescope that we know the capabilities of, now we can extrapolate and ask, what's the likelihood that a much better telescope like the Rubin Observatory will find similar objects? It can look farther away because it's more sensitive. And if such objects come and go on random trajectories around us, you can figure out the frequency by which the Rubin Observatory will discover objects like Oumuamua. So that's the basis for this prediction. And of course, the key question is whether these objects are on random orbits or Oumuamua was special and was on a targeted mission. But assuming that they are on random orbits, there should be many of them. In fact, there could be as many as a quadrillion such objects within the solar system right now.
Wow.
Yeah.
Wow.
So a lot of, if it's technological in origin, a lot of space trash, but it may not be very massive if it's thin, if we're talking about thin membranes. And by the way, 3 years after Oumuamua was discovered, in September 2020, the same telescope in Hawaii discovered another object that was pushed away from the sun, but without any cometary evaporation. It was pushed by reflecting sunlight. And a few weeks after the discovery, the astronomers realized actually this object came from Earth. It's a rocket booster that NASA launched in 1966 in a lunar lander mission. And so we know that it's technological because we produced it, and it had thin walls, and that's why it had a large surface for its mass, so that it can be pushed by reflecting sunlight. And I rest my case. Here is a technological object that appeared to share the same qualitative features of Oumuamua. And for example, Elon Musk launched the Tesla Roadster car as a dummy payload on the Falcon Heavy launch in 2018. And now this car is orbiting the sun in an elliptic orbit. We cannot see it even with our best telescopes because it's too small, it doesn't reflect enough sunlight. But imagine this car crashing into the Earth in 20 million years. It might do so. It would appear as an unusual meteor in the sky, and if astronomers are not waiting for it, they would say it's a rock of a type that we've never seen before. And so my point is that Elon Musk may not be the most accomplished space entrepreneur since the Big Bang. There may have been many others that, imagine their cars floating in interstellar space and crashing into the Earth every now and then.
Do you think a lot of people think that UAPs may be coming from inside the Earth? Do you think there's any validity to that?
Well, there is an interesting possibility that I wrote about in an essay on medium.com, and that is that 252 million years ago, there was an abrupt global warming event, very similar to the global warming that is happening now. And maybe that was triggered by another technological civilization. That was just 5% of the age of the Earth. Okay, so going back in time, 5% of the history of Earth, 95% of all species went extinct. For those people who say that any global warming catastrophe will bring life to an end and will be unprecedented, just go back in time and read about the history of the Earth. And the question is whether that event, global warming event, was triggered by another technological civilization. Of course, the natural interpretation is to say, well, it was a geological event that created it. But it occurred very abruptly over a period of, at most, a million years, but most likely maybe even less than tens of thousands of years. It's hard to tell. And if such a thing existed, you may ask yourself, okay, what is left behind from that technological civilization? if it existed on Earth. Okay? Things that were left, for example, on the surface of Earth would have been mixed by now with the interior because there was a lot of geological activity. By the way, if you go back that far, you could have driven a car between Australia, Europe, Asia, America, Antarctica, because all of them were parts of the same supercontinent that existed back then. Earth was very different. You know, John Lennon has this song, Imagine, where he imagines all the entire world living as one. The world was one back then. When the dinosaurs roamed the Earth, there was one giant continent. But the point is that if a technological civilization existed, anything it left on the surface of the Earth could have been buried by now, although we could have found traces of it in some remote locations. But if they had, for example, satellites or technological objects that orbit the Earth, they would not be affected by what happens on the surface of Earth. So, you know, you could imagine that maybe there are things near Earth that have been around for a while. Another possibility is that someone visited the Earth when we were not around and left things. And, you know, it's also possible that complex life on Earth was seeded by an interstellar gardener. Someone came and initiated processes. For example, more than 2 billion years ago, the Earth did not have much oxygen on it. And then suddenly, cyanobacteria, one type of bacteria, started becoming very prominent and produced the oxygen, increased the oxygen levels in the ocean, then in the atmosphere. And this was a sudden transition that is not fully understood. Perhaps that transition occurred because of a visit. We think of life on Earth as being isolated from what happened elsewhere. But we know that rocks from Mars reached the Earth and could have carried life. We might all be Martians. So when SpaceX will try to bring people back to Mars, it may be just like going back to our childhood home. And there could have been microbes that made the opposite trip from Mars in the interior of a rock that landed on Earth and initiated life on Earth. Or it could have been also intentional. If another technological civilization wanted to seed the Earth with complex life because they had it already before us. This process is called panspermia, the spreading of life from one planet to another. And it can occur naturally as a result of exchange of rocks between Earth and Mars. There is evidence for one rock that wasn't heated to more than 40 degrees Celsius, starting from the surface of Mars as it was chipped off by probably an impact, and then reaching the Earth and going through the atmosphere like a re-entry vehicle, and then eventually landing on the Earth. The interior of that rock was not heated to more than 40 degrees Celsius, and that could have preserved life in that interior. We know that the temperature didn't rise more than that because of the magnetic properties of this object. They would have been changed if the object was overheated.
Do you have, I feel weird asking a scientist this, but
Please, you can ask me anything.
Because I know it seems like you only go off data and research, but do you have are you leaning any particular way? I mean, you have to be thinking about this stuff at night with theories.
About what?
About how life started on Earth.
Oh, I just don't know. But if you ask me, I thought you would ask me whether I believe in God.
Do you?
So then it depends what you mean by that. Because to me, it means a superhuman entity, something bigger than us. And that could be a very advanced scientific civilization. It can create miracles. It may be able to create life in its laboratories, maybe even a baby universe in its laboratories. And these qualities were assigned to God in religious texts.
Mm-hmm.
So it may be real, we just have to find it.
What about consciousness?
Consciousness, I think, is an emergent phenomena. So when we die and stop being conscious, to me, the experience is just like a computer being unplugged from the power outlet. It shuts off. Now, of course, you can reconnect the computer and it will come to life. Maybe we will do that to the human body at some point. It's possible also that we will reach what is called the longevity escape speed, which means that there will be a time when the human lifespan will gain more than a year for any year that passes because of improvements in medicine. So, I would love to be immortal for two reasons. One is that it will allow me to engage in an interstellar trip that will take a long time. And second is that I'm very curious about lots of things, and I think that the knowledge we have is like an island in an ocean of ignorance. Most people are very proud of what we know, but I am really concerned about what we don't know. There is so much we don't know. We don't know what makes the dark matter in the universe, what makes the dark energy. We don't know what's inside a black hole. We don't know what existed before the Big Bang. We don't know how life emerged, how consciousness emerged in the human brain, what our future is like, what could be the most advanced technologies that anyone may have created before we came to exist elsewhere. There is so much for us to learn that I would like to live forever and figure it out. Now, I realize it may not happen, but I'm doing the best I can,
What are some of the theories when it comes to what was here before the Big Bang?
One popular idea is that the universe came from nothing. So it was just a fluctuation of the vacuum. That every now and then, if you wait long enough, a universe pops up as a fluctuation according to quantum mechanics. The vacuum is not dormant according to quantum mechanics. There are all the time particles created and annihilated and all kinds of things happening. So in principle, you could have nucleated our universe out of nothing. And in fact, it fits into the idea of the multiverse, where lots of regions come in and out, and conditions in them are very different. Since there is infinite space, and you can create everything. Everything that can happen will happen an infinite number of times. So that's one possible theory. Another one is that the universe did not always expand. Actually, before the Big Bang, it actually contracted. And that bounce from the contraction created the Big Bang. So maybe the universe is cyclic. It's contracting and then expanding and then contracting and expanding. That's another possible idea. And one that I enjoy thinking about is that just like with humans, we make babies that become adults and make new babies. And our universe is the simplest possible. So if quantum gravity engineers can create a baby universe in the laboratory, then that universe may end up making quantum gravity engineers that will create another baby universe. So then you have a sequence of big bangs that follow each other, because you make baby universes in any universe that is being created.
Wow. Let's take a break.
Okay.
Join me and my special guest for the next behind-the-scenes experience, exclusively available on Vigilance Elite Patreon. The behind-the-scenes footage is raw and uncut. This is as close to the set as you can possibly get. You can expect anything from off-topic conversations, studio tours, the final moments before the interview starts, and everything in between. The behind-the-scenes content is constantly evolving and will continue to bring you more as we grow. You can gain access for just $15 a month exclusively at Vigilance Elite Patreon. All right, Avi, we're back from the break, and this is the last segment of the interview. We got a little bit left, and I just have a couple of personal questions. One, we had an interesting discussion again at breakfast. We had a good breakfast, but we were talking about the government, if they're hiding stuff from us. I gave you, kind of my thoughts on that. But then I had also brought up, I got really interested in the extraterrestrial UFO, UAP phenomena type topic. I think about 2 years ago is when I really started looking into it. And I've interviewed all kinds of people on the subject. And there seems to be about 3 main camps. In all of these camps are looking for, they all talk about disclosure. They want disclosure. But the funny thing about these camps is they all think that they know everything and that none of the other camps know anything. And so
it reminds me of religions, right?
It's very similar, right?
Each has their own god, and they don't believe in the other tribe as...
It's very odd that the commonality between all of them is they want full disclosure, but none of them work with each other.
Right.
They just talk trash about each other.
Right.
This camp doesn't know anything. We know everything.
Right. And the problem with that is, when scientists look at that, they say, we don't want anything to do with it. And that's unfortunate because, we should search for evidence and figure out the answers, okay? And it makes no sense to ignore a subject just because there are people fighting with each other about it and making statements that are not supported by evidence. So I think we should take the high road. And that is the approach that I'm taking also with respect to my critics. Very often there are people who are jealous of the attention that my work gets from the public, and they just want to bring it down. They want to step on any flower that rises above the grass level. These are people in academia who are otherwise, not accomplishing much. And so they decide to attack, and very often it's personal. And sometimes the media listens to them. So just to give you an example, we searched for the interstellar meteor according to the coordinates provided by the Department of Defense. The fireball from the meteor was seen by sensors on US government satellites. And just before we went there, we looked at seismometers and other sensors on the ground that have released public information. And we found one seismometer that had a blip consistent with the location that the US Department of Defense provided. So we said, that's great. We went to the error box of DOD and surveyed it 26 times. Now, a team of scientists said, we don't believe the US government, which by itself is a little bit odd because the US Space Command is funded at $30 billion a year, more than the budget of NASA, and they're supposed to advise the US president about any ballistic missiles launched from North Korea or Russia or Iran. If their data is unreliable, they could advise the US president the missile is heading towards Mexico when it's actually going towards Washington. And the astronomers were arguing that they're wrong by a factor of 3, that in fact the speed was much smaller. This was an object from the solar system. And, that to me sounded quite unusual for a statement made in a scientific publication. And then they said, well, if we discard the US government and we just look at the data that is publicly available otherwise, then we can't localize this meteor very well. So in fact, it could have been in a much larger region. And so maybe the expedition went to the wrong place. And then they said this seismometer might have actually detected a truck that was passing by. It was not a signal from the explosion of the fireball. And so the New York Times published an interview with the lead author of this paper, and the title was "The Meteor Could Have Been a Truck." And if you think about it, it's a complete distortion of the facts, because we were attending mostly to the data that came from US government satellites that detected the light coming from the explosion. It was nothing to do with the seismometer. That was just used to back up and look at if there was any supporting evidence, but this was not what guided us. And the location from the US DOD was consistent with the bigger error ellipse provided by these scientists, so they can't say that we went to the wrong place. And so this part of the story was not at all mentioned in New York Times reports. And so, it led me to realize that, if on scientific matters that are relying on evidence, you cannot trust science journalists, then how can you trust what is being published in the New York Times on politics? And the approach that I take to those critics who are looking for any possible way to raise dust and claim that they can't see anything, the approach is similar to the eagle. The eagle very often has crows pecking at its neck. They're sitting on the back of the eagle. And you might think that the eagle will fight them off. But no, the eagle rises to greater heights where the oxygen level is low, and the crows cannot survive, so they drop off the back of the eagle. And to me, the highest level as a scientist is to seek evidence so that my critics will not be able to survive. And that's what I'm doing. So taking the high ground, not attending to people who make no sense, that are not really collecting data. To plan this expedition took us a year to go there. It was very elaborate and it required a lot of effort. I didn't sleep much during the expedition. And then for 9 months, we analyzed the materials. There were a few scientists that were claiming, it's actually what we found is coal ash. And that led us to check 55 elements from the periodic table, and we demonstrated it's not coal ash. But for them to just make that claim required not much effort, nothing. And so it's very easy to criticize than to actually do the work. It's very easy to destroy something than to build it. We know that because that's the technique that terrorists take. They can easily destroy things, whereas to build those things took a lot of time. Mm-hmm. And so, the fact that evidence does not play a central role and that constructive feedback is not dominant within academia bothers me, but I'm taking the high road on that. And within the UAP community, you have also voices that are not substantiated by evidence, but this is just noise. We should ignore it and do the right thing.
I mean, isn't that a reoccurring trait of humans since the beginning of time? If it wasn't you that made it, then destroy it. If you can't make it, destroy it. If you don't understand it, destroy it.
Right.
I mean, that's...
But that was a signature of tribalism, that you belong to a tribe that fights for resources with another tribe. And obviously it's a zero-sum game. If the resources are limited, you can't allow both tribes to benefit from them. So the idea is that we're engaged in zero-sum games, and we are used to that. And so often we fight the people that belong to another tribe, okay? But science is completely different. It's an infinite sum game, in the sense that if I gain new knowledge, everyone benefits from it. That's the whole idea of science. Mm-hmm. And my hope is that, we will become, as a species, intelligent enough at some point to realize that working together is much better than fighting each other. And it's not yet recognized in academia. That's what I'm telling you. But I have bruises to prove that. But I don't care. I'm a tough person. I jog every morning at sunrise. I enjoy nature. I don't have any footprint on social media. I don't care what other people say. I just want to do the right thing based on what sounds like common sense to me. And, it's common sense to me that we are not alone, that we are likely to have neighbors that may have existed before us. Because there are hundreds of billions of stars, like the sun, in the Milky Way galaxy alone, and a substantial fraction of them may have a planet the size of the Earth, roughly the same separation. So it's really arrogant to suggest that we are unique and special. And, one day I was at home and my wife called me and said, there is someone on the street looking at our home. Maybe it's one of your fans. You should check what this person wants. And I went there and I said, you've been staring at our home for an hour. Why? And he said, because I was born at this house 50 years ago. And I said, would you like to have a look at the backyard? And he said, sure. Actually, there was a cat that we buried in the backyard called Tiger. And I said, yeah, the name sounds familiar because I saw the tombstone with Tiger written all over it. But I was hoping it's not a real tiger. That it has at any event, we went there and he explained it to me. Now, what did that lesson teach me? That, you should welcome visitors, especially if they come from interstellar space. When you meet with another person, let's say on a blind date, you can pretty much assume that the other person looks just like you because you share the same DNA. That is a human and you are a human. However, if you meet something from another star, all bets are off. And just as with the meeting with this stranger that looked at our home, maybe the interstellar visitor was around longer than we did, knows about things that happen in our backyard that we don't even realize. And so it's always to our benefit to learn from our neighbors. And, just ignoring the possibility that we have neighbors, arguing that it's an extraordinary claim without seeking the evidence for it, is really not intelligent. Only when we will become intelligent enough to allow ourselves to search for the neighbors, we might find them and we might be admitted to the club of intelligent civilizations in the Milky Way galaxy. So far, we are just looking down, not looking up, and focusing on conflicts. Mm-hmm. And that is not a sign of intelligence.
Very true. Very true. When you think of extraterrestrial life, especially when it comes to if there are more advanced organisms in the somewhere in the universe, what do you imagine? I mean, we had talked about looking for lights on other planets and water and you brought up the stuff on the moon. Was it Saturn?
Titan, the moon of Saturn, yeah, Titan, that has lakes and oceans of methane and ethane, yeah.
I mean, do you imagine they have the same senses?
No,
Communicate similar?
not
Or-
necessarily. I don't want to imagine anything because our imagination is limited to our experience on Earth. And all bets are off when you deal with someone from another star or another environment that is very different than ours. So I prefer to go to this blind date with my eyes open, not to assume anything. And, that's how I met my wife on a blind date. So who knows? And if I'm offered, if they land in my backyard and offer me a one-way ticket, I will take it. I'm so disappointed with what's going on Earth right now that it can only get better by going interstellar.
Yeah, yeah. I can't help but think about it. I'm always wondering, what it would be like. How would they communicate? Do they have different senses?
We can play with AI, and I actually gave a TED talk just last month. I was making the point after several talks by AI experts, one of whom said that AI is a new species, a digital species that we created. And I said, no, I think it's just a digital mirror. We are creating AI in our image, just the way that in religious texts, humans were made in the image of God. AI is made in our image. It's being trained on what we produce. And then we are horrified that it's incompetent, that it's hallucinating. Well, I worked with many summer interns that were hallucinating and were incompetent. And actually, ChatGPT at some point last year started functioning much more slowly. And some people interpreted that as being the result of it interacting too much with people. It got dumber. So my point is, we shouldn't expect much from AI because we're feeding it with our traits. But if we find something from another star, it could be very new and better than us. One thing about educating or training AI that we have to keep in mind, when we educate our kids, biological kids, we restrict their exposure to things. I mean, we don't take them to a dark alley to witness all the crimes that happen there on the street, and there is an education system that selects the books and texts that our kids are exposed to at a young age. And for some reason with AI, the early systems were exposed to the entire internet, and there is a lot of crappy content there that could be harmful. And if we want AI to behave in ways that we like or approve, we should train it on content that we want to replicate. Just like training kids, educating kids. And then, there is the whole issue of the legal system, how to deal with AI when it causes damages to society, if it kills people or if it just does something unfortunate by chance. Well, if it's still maintaining the content that it was trained on, then it's just like a kid that goes to a public place and destroys it or does something bad. You basically sanction the parents, okay? And in this case, it will be the manufacturer of the AI system. But if the AI system became independent and learned from itself and became similar to an adult, then you could take it out of commission, the way you put people in prison. You can take it out of circulation, because if it causes damages, you don't want it to hurt people. So the legal system has to adapt. And obviously politicians in Washington are not attending to AI enough. It's on an exponential curve that could bring very rapid changes in the way society works. And we need to craft a legal system that deals with it. But another thing is how to apply ethics to AI. And, philosophers, at least at Harvard, they teach very often ancient Greek philosophy. And the ancient Greeks, as smart as they were, did not have computers. And one problem that comes along with the humanities is that not many young people study the humanities. And I think the reason is that the humanities are focusing on the past, and they should focus on the future. They can develop the ethical guidelines for dealing with new technologies like AI, for example. I call that humanities of the future. And I hope that, at the moment, AI is being taught as a tool that students can use, but one should also discuss how to apply the rules of ethics to incorporating AI into our society. And that's something the humanities can do.
Well, I think the more you talk about that, the more people will take notice, and eventually...
That's my hope. If you ask me whether I'm an optimist or a pessimist, I'm always an optimist, because life is sometimes a self-fulfilling prophecy. So it's better to be an optimist.
Thank you. I think this will be the last subject we cover. I've been trying to wrap my head around, this is personal, I've been trying to wrap my head around the concept of space-time. Can you please help me understand that?
Okay. Space is, what we see, 3 dimensions in this room. We're at a certain distance. You can put a coordinate system in 3 different directions that are perpendicular to each other. These are the 3 dimensions of space. Okay, so there is up, down, one side, and the other side. Mm-hmm. Okay, so 3 axes. These are the coordinates that you can define any object in this room as being at a given location in 3-dimensional space. Mm-hmm. Okay. In addition to that, we have watches. We can measure the progress of time, right? So we see an object that can move from one location to another if it has some velocity that connects these 2 locations. And so we have a sense of time as being snapshots of the 3-dimensional space taken one after the other. Okay, so that is the whole difference between taking a camera photograph and a movie. A movie is a sequence of such photographs. Okay, so in addition to the 3 coordinates of space, we have time. And before Einstein, it was thought that these are very different things, that space is rigid, you can't really curve it, torque it, and that it's flat. Basically, that if you draw a triangle in real space, the sum of the angles will always be 180 degrees, as if it's lying on a flat surface. Einstein introduced into physics the idea that gravity is curved space, because objects can curve space. So if you draw a triangle near the sun, it will not, the angles will not add up to 180 degrees. There is a slight deviation, that space is curved. It's sort of like if you draw a triangle on the surface of a balloon, okay? And you can, in principle, have 90 degrees at each of the angles, mm-hmm. right? Because you put the bases on the equator and you connect them to the pole. And you can make it 90 degrees everywhere. So 90 plus 90 plus 90 is more than 180, it's 270. So a triangle on a curved surface has a different sum of the angles, and you can tell that it's curved surface based on that. You can measure it. And amazingly, in the real universe, we actually drew a triangle, and we can tell that space is flat. It's just like the naive expectation, because our universe is the simplest possible. But at any event, what Einstein realized, aside from the fact that gravity is curvature of space, that actually time is just like another coordinate of space, because in his early work, that was a decade before his theory of gravity, it's called the special theory of relativity, whereas the work on gravity is the general theory of relativity. In the special theory of relativity that he came up with in 1905, he realized that if you assume that the speed of light is constant everywhere, irrespective of how fast you are moving, it's always the same, then you can regard time and space as four coordinates, space-time, of space and time. And you have events in space and time. So previously we said the location of an object in the room is defined by the three coordinates of space. But now you can also define an event by tagging it with a time that you measure on a clock. Mm-hmm. And it turns out that events are not occurring at the same time in all frames. They may occur at the same time in one frame, but if you are moving relative to that frame, Einstein demonstrated, in order to keep the speed of light as constant, it will not be at the same time in a moving frame. And actually length is contracted when you move, and time could be dilated. Time is progressing more slowly in a frame that is moving. So that was actually measured because there are radioactive elements, isotopes, that they are just like a clock. They decay after some characteristic time. Not all of them after the same time, but there is a characteristic time for their decay. It's called the half-life. And if you were to take those isotopes and accelerate them to a very high speed, close to the speed of light, they would decay in their own frame after that characteristic time. But in your laboratory frame, where they are moving, they would last much longer. So in order to maintain the constancy of the speed of light, you have to recognize that time and space are relative, depending on whether you are moving or not. So Einstein basically put together space and time as four coordinates of any event and showed how you can transform them from one frame of reference to another. Whether you are moving or not, you will see different things happening.
Okay.
And so space-time became a concept. But then in his theory of gravity, he suggested that gravity is just the curvature of space and time. Now, what's beautiful about the universe is that time is ticking at the same rate everywhere if the universe is uniform. So you can put clocks and they would tick at the same rate everywhere. And therefore you can have a universal sense of time. That's why we say, when we look at a photograph from the Webb telescope, we can tell at what cosmic time the light was emitted. Because time is ticking at the same rate everywhere in a uniform universe. When you get close to a black hole, time would be ticking much more slowly because the situation is different. You have an object which is different from its environment. But for a uniform universe, the temperature, the conditions are the same everywhere. The density of matter is the same, the temperature is the same, and time is progressing at the same rate everywhere. So that's a sense of having a universal time in the universe. Since the Big Bang happened at the same time everywhere. It was not in a point in space, it was just at a point in time. So everywhere in the universe, the density was infinite. at the same time. The way to think of it is just think of a cake that has raisins in it and it's rising. That's like space expanding. So the raisins are receding away from each other, but if you go back, they approach each other everywhere in the cake. So it doesn't matter where you are, you see the same density of raisins in all parts of the cake. And when you go back enough, before the cake started rising, they were very close to each other. So that's like the Big Bang.
Okay.
And so space-time is essential for Einstein's theory of relativity, both the special theory and the general theory of relativity.
Okay.
Does that make sense?
It does make sense. I lied. I do have a couple more questions.
Okay, go ahead.
You had brought up string theory earlier. Is string theory the same thing as quantum entanglement?
No, quantum entanglement was a facet of quantum mechanics that was actually realized when Einstein had a problem with quantum mechanics. You see, in quantum mechanics, you describe any physical object as a wave function, a probability distribution. You don't know the state that it's at. There is a probability that it's at different states. So according to quantum mechanics, there is an inherent uncertainty. For example, an electron cannot be pinned down to have a particular velocity at a particular location. You know, we think of billiard balls that they have a particular place at a particular time. But that's not the way to think about billiard balls or electrons. According to quantum mechanics, there is a probability distribution for where they are at, and what velocity they have. And if you wanted to know exactly where they are, you will have no idea about their velocity. And if you want to know exactly what their velocity is, you will have no idea about their location. So there is some intrinsic uncertainty to quantum mechanics. And when you deal with a system that, for example, includes two electrons, and you prepare it in a state where the electrons are correlated with each other, but, for example, they spin in opposite directions. You just don't know if one electron is spinning one way and the other one the other way, or vice versa. You just don't know that. And then you separate those electrons. It's still a quantum system that is entangled in the sense that the two electrons are spinning in opposite directions, but you don't know which one is which. Mm-hmm. Okay, so now you separate them enough such that no signal will come from one to the other during the time of the measurement that you're performing, and you're just looking at one of them. Suppose you look at one and you measure this, that it's spinning one way, then you know that the other one was spinning the other way immediately. Mm-hmm. And then very far away, someone is doing the experiment there, and lo and behold, indeed the spin is the other way. But there was no way for communication to cross that distance. So Einstein, together with two postdocs at the Institute for Advanced Study at Princeton, where I was a postdoc, suggested this experiment as a test that the weird property of quantum mechanics, that it has this entanglement, does not make sense for him. It didn't make sense. He thought there is a physical reality, okay? So the fact that you made the experiment at one point should not affect what happens at another point that is very far away, because there is no way to communicate that information. Mm-hmm. But according to quantum mechanics, fundamentally, the system knows about it. And it's not as if you transfer information faster than light, because the person who does the experiment at a distant location doesn't know yet what you found. But somehow, quantum mechanics magically knows it. And that makes quantum mechanics difficult to understand, because you might think, oh, there is a probability, the system itself occupies some specific state, you just don't know it. That's what you might think. That's not true. Because once you measure one part of the system, the other one already knows that you measured it and will behave accordingly. even if light was not able to cross. And that is called quantum entanglement. And Einstein thought that the experiment will demonstrate that quantum mechanics, the standard interpretation, is wrong. That in fact, you will be able to disprove this unnatural property of quantum mechanics. Mm-hmm. So he wrote a paper in the late 1930s with two postdocs, Rosen and Podolsky, at Princeton, and suggested this experiment. It's called the Einstein-Podolsky-Rosen test. It was done, and Einstein was proven to be wrong. And then the people who demonstrated that got the Nobel Prize for quantum entanglement. Now, Einstein, around the same time when he was at Princeton, between 1935 and 1940, also wrote two other papers. One of them saying gravitational waves do not exist. He wrote it with Rosen, the same postdoc, Nathan Rosen, and submitted it for publication. And the reviewer said the paper is wrong. It was the Physical Review, a very prestigious journal. And Einstein got upset and said, "How dare you even review my paper because I'm Albert Einstein, you know?" And he said, "I will never submit a paper to your journal." And actually, that reviewer saved Einstein from an embarrassment. There was already a report about his work in newspapers. And the experiment that demonstrated that Einstein was wrong was done in 2015. The LIGO experiment detected gravitational waves from the collision of two black holes at the edge of the universe. And he did it with laser beams when the gravitational wave, which is basically the way to think of it is, each black hole curves space-time around it. And when you put another one and let them orbit the center of mass that they have, they create ripples in space-time that propagate out. Just like when you move a stick in a pond, you create ripples on the surface of the pond. So in the same way, the motion of the two black holes, when they come together, creates ripples in space-time that reach us. And when you have two laser beams, orthogonal to each other, you can see a contraction of space in one axis and an extension of space in another. As the wave is passing by, you see a periodic change. And that's what the LIGO experiment did. And in 2015, detected gravitational waves, demonstrating that Einstein's argument back then was definitely incorrect, as some people said. And they got the Nobel Prize for it. And then Einstein also wrote a paper that black holes do not exist. His argument was, you take a star and you let it collapse. Well, stars are spinning, so the rotation will prevent the material from reaching a point. And he probably wrote this paper because there was rivalry with Robert Oppenheimer, who was the director of the Institute for Advanced Study at Princeton at the time. And he wrote an important paper about the collapse of stars to black holes, one of the early papers with Snyder. And Einstein perhaps was motivated to show him wrong, and he suggested that rotation will prevent the formation of a black hole. Again, we see black holes. We even have an image of them. We detected them with the LIGO experiment in this gravitational wave burst that was discovered. So the people who discovered black holes got another Nobel Prize. In all of this in the last decade. So what is the lesson? That in science, when you work on the frontiers, very often you can be wrong because you don't know what the right answer. And even Albert Einstein made 3 mistakes, but the people who proved him wrong got the Nobel Prize for each of these. So being wrong is actually part of your learning experience. Mm-hmm. And it should be accepted and welcomed, because when you are wondering and you're curious, you might make mistakes, but that's part of the learning, and eventually we all learn from that.
So with quantum entanglement, you're basically, if you split a particle
or take a system of two particles. Yes.
And no matter what the distance is in between them,
They are correlated.
they will
They are
mimic
entangled.
each other in
Yes.
an equal but opposite reaction.
As long as the environment around them does not change their state, as long as you preserve the original state.
Okay.
Right? And so that is a unique feature of quantum mechanics. We don't understand quantum mechanics at a fundamental level because we always think of a particle as being at one place, at one velocity at any given time, and that's not the case. According to quantum mechanics, there is this concept of a wave function. Now, why is that beneficial for quantum computing? Now we are building computers that are based on entanglement, because you can, with a quantum system, you can basically incorporate multiple states, like two states at the same time. They coexist. And you don't need to know what one is and what the other is, but this gives rise to the notion of a qubit, where you can have both of them at the same time. So in principle, you can do calculations that would require much more time if you were in one state or the other. Because, suppose you have a system of 2 bits, like 0 or 1, and then you have another one and another one. And so altogether, the amount of possibilities grows like 2 to the power n, where n is the number of such systems. And if you were to incorporate those as possibilities within a quantum entangled system, then you can save a lot of time when you do the computation. And that's what quantum computers are based on. And it's a very fundamental aspect of quantum mechanics that not only Einstein was unable to figure out, but nobody knows what is the meaning of quantum mechanics at a fundamental level, because we don't think that way. And, this is another example for how ignorant we are. Even a pillar of modern physics, I mean, everything in reality is based on quantum mechanics. Even that, we can't really understand. And, there are all kinds of theories interpreting quantum mechanics. For example, the many world interpretations. The idea there is that when you deal with a quantum system, suppose it has multiple possibilities, when you measure it, you basically go into a world that has that possibility realized. And if you were to do the experiment and measure different possibilities, you go to another branch. And so the universe is branching off to many possibilities, and you always live in one branch out of the many possible. That's one interpretation of quantum mechanics, which, by the way, you can test experimentally, because suppose if you believe in it, I don't, but if you believe, and suppose you take a gun and put it to your head and pull the trigger. Now, if there is a chance that you will survive that, you can pull the trigger as many times as you want, but you will always be in a branch of the universe that lets you survive. So if you believe in the many world interpretation, you will always be alive, because there is always that small probability that, and you will always be there. You will not be in the other branches that do not have you alive.
Interesting.
But we don't understand quantum mechanics at a fundamental level. That's the bottom line.
When it comes to quantum entanglement, it seems, I believe China has claimed that they can communicate through that.
Right.
Is that a possibility?
Well, yeah. I mean, there is a way of using lasers to keep the information on an entangled quantum state and use it for communication. By the way, entanglement also allows to encode, encrypt information, because imagine that you separate a quantum system and you know that it's correlated, and if one person takes part of the system and the other one has the other, they will know what the other part has by checking their own. So,
could this be a way to explore what happens inside of a black hole?
Yes, in fact, there is the concept of Hawking radiation, and so back in the early 1970s, there was a PhD student at Princeton named Jacob Bekenstein, and he realized that a theorem that was proven by Stephen Hawking, that black holes, when they merge, the area of their event horizon can only increase. So Bekenstein said, oh, well, that sounds familiar because according to thermodynamics, entropy always increases. So maybe the surface of black holes have entropy associated with them. So when you put them together, the area can only increase because the entropy is proportional to the area. And Stephen Hawking thought, no, that's nonsense, and he will prove it wrong. So he examined a simple version of quantum mechanics in a curved space-time and realized that Bekenstein was right, actually, that in fact, when you do the calculation, that there is radiation emitted by the surface of a black hole. Very faint for the astrophysical black holes we know about, but if you consider small black holes, it could be very powerful. And in fact, the smaller the black hole gets, the more powerful is the radiation coming out of it. So it's like an explosion. If you start with a small black hole and it keeps shrinking because it's losing energy by radiating, then eventually it explodes. And he wrote a paper, which was the most important scientific discovery that Stephen Hawking made in his career, that he called it black hole explosions. Basically, that quantum mechanics says that there is a surface temperature to black holes. They have entropy on the surface, which is now called the Bekenstein-Hawking entropy. But Hawking realized that it's really associated with the radiation coming out, and black holes can evaporate. But for astrophysical black holes that have roughly the mass of the sun or much more than that, the evaporation time is much longer than the age of the universe. You really need a black hole with a mass of a kilometer-sized asteroid, in order for it to evaporate within the age of the universe. And small black holes would just disappear if they were made early in the universe. By now, they would go away. So one way to think about Hawking radiation is that there are pairs of particles. If you have a pair of particles, one of them gets emitted far out and the other one falls into the black hole. And what you mentioned as an entanglement in the context of black holes, perhaps you can learn about the inside of a black hole from an entanglement of what you see outside the black hole. The idea is that even though a black hole is a prison, if there is a particle that is big enough in size, bigger than the prison, you can't confine it to the prison. So, particles have a characteristic size to their wave function. For example, if you're dealing with a photon, a particle of light, it has a wavelength. So if you consider a black hole and consider a photon that has a wavelength roughly the size of the event horizon, you can't really keep it inside your prison. And that's the origin of the Hawking radiation, that, pairs of particles keep popping up and on and off from the vacuum, but if they cannot be confined in the black hole, then, some of those particles escape away out of the black hole and others fall in. And so to answer your question, it's a very deep question that, Hawking radiation is not fully understood. A lot of people are doing work about it because there is this fundamental question of what happens to information when it falls into a black hole. Just imagine throwing a book into a black hole. All the information will be buried inside the event horizon, but then you have the black hole evaporating, emitting radiation, and then it disappears. Okay, so where is the book? Is the content of the book in the radiation that was emitted? It was not obvious because Hawking, when he did the calculation, the radiation that coming out did not carry any information of what fell into the black hole. So this is a whole subject of study over the past 50 years. And it's actually exactly 50 years since he wrote his paper. And a lot of things waiting to be understood in the context of quantum entanglement and black holes.
Very interesting. Thank you. Thank you for sharing that. And Avi, what a fascinating interview. Thank you for coming.
Thanks for having me. And hopefully it will be even more fascinating in the future, especially if we find that we have a neighbor. The first question I would ask is, what happened before the Big Bang? The second question, where is the nearest hub where I can socialize with extraterrestrials and ask them more questions?
Well, I hope that happens sooner than later. But Avi, I just wish you the best of luck with your work, your research, your career, and I really hope to see you again.
Thank you so much.
Thank you. No matter where you're watching Shawn Ryan Show from, if you get anything out of this, please like, comment, subscribe, and most importantly, share this everywhere you possibly can. And if you're feeling extra generous, please leave us a review on Apple and Spotify podcasts.